9. Ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and lift off.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
À tous DDO, attention pour le décompte final.
We'll let you watch the countdown. We'll be back after liftoff.
9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage UAB, décollage. Tous les paramètres à bord sont normaux.
Beautiful, beautiful daytime shots, which we don't always get, of Ariane roaring off the pad into the sky over French Guiana. The DDO is saying all is nominal, all is okay. On board at 17:54 local time, and right on time she took off, lifting off from the ground with Intelsat and HILAS 2. These shots are always impressive for the people at the observation posts around the site, which are always full up. I don't know if you saw it, minus 12 seconds, the computers gave the command to open the water deluge. They sent in 1,500 cubic meters of water, mainly to deaden the noise. Right now, Ariane weighs 775 tons.
Tous les paramètres à bord sont normaux.
And everything's normal. She's burning 5 tons of fuel every second, 2.5 tons in each booster, and the core stage is burning another 300 kilos per second. Ariane is following the program in the onboard computer, which gives all the orders, including stage separations. We'll soon start to see those. The vehicle equipment bay is the cockpit of the launcher, if you will, orchestrating all the flight commands, all the piloting orders, and all the equipment on board is doubled, which means there are backup systems for everything. We're in the first of 4 flight phases. The first 3 are powered, the last is not. We'll describe each in turn and in detail so you can follow Ariane as she heads across the Atlantic, where she'll separate the 2 satellites over both coasts of Africa. Right now, the first flight phase, the single Vulcan core engine and the 2 boosters are burning. The boosters will burn just over 2 minutes. They're the first to be extinguished, and you'll hear the DDO call that out. And that looks like the flame out of the boosters right there.
Séparation des étages, accélération à poudre.
And right on time, the DDO has called out separation. You see the 3 points of light, 2 boosters on each side, and the single point of light in the middle. That's the core stage that continues burning. The boosters fall 500 kilometers from the shore in a protected area. Before the boosters are empty of their fuel, the push diminishes, and this is what the onboard computer senses, a drop in acceleration, and decides to separate them, and they're separated 1 second later. Beautiful.
La trajectoire est normale.
We may even see the fairing separation on the screen. Take a look on the upper left. You have the cursor crawling up the line there. There are actually 2 lines. One is superimposed on the other. One is the nominal trajectory. One is the real-time trajectory. As long as they're one on top of another, we're right where we should be. And below that, 2 lines, A in some numbers and V in some numbers.
Séparation de la coiffe.
A is altitude and V is velocity, our speed. And we've just had separation of the fairing right on time. You can see what that looks like. There are 2 halves. The other half is out of camera range.
Good evening and welcome back to the International Space Station Flight Control Room at the Johnson Space Center in Houston. Just a few hours ago, a new spacecraft, an unpiloted Russian Progress resupply vehicle, was launched from the Baikonur Cosmodrome in Kazakhstan. And now, just about 5 hours after this launch, you're looking at the replay of the launch that took place at 2:35 and 13 seconds p.m. Central Time, 1:35 and 13 seconds a.m. Baikonur time on Thursday, August 2nd. Now we are just 39 minutes away from an accelerated docking of the Progress vehicle to the International Space Station, testing out a proof of concept for the Russian side to provide an accelerated rendezvous capability for not only Progress vehicles, but perhaps for manned Soyuz vehicles in the future. Here in the Space Station Flight Control Room here in Houston, the flight director on console at this hour is Mike Lammers. He is the second from your right. Judd Freeling, another flight director, joining Lammers on console this evening. And to Lammers' right, Lammers wearing the dark jacket, to his right is spacecraft communicator Rob Hayhurst, who is communicating with the space station crew on board the International Space Station when required this evening. This operation tonight is being controlled half a world away at the Russian Mission Control Center in Korolyov, the town just outside of Moscow. You're looking at a view from a balcony camera overlooking the International Space Station Flight Control Room at the Russian Control Center, where flight controllers are currently monitoring the status of the Progress 48 resupply craft as it steadily closes in for a docking with the International Space Station's Pirs docking compartment at 8:24 p.m. Central Time this evening. This accelerated rendezvous profile being employed by the Russians tonight has been in the works for some time now. It is designed to accomplish several things. First, to increase the crew's ability to arrive at the International Space Station without the cramped confines of a Soyuz vehicle over a 2-day period. Also increasing the post-undocking free flight life support margins from 2 days to 4 days at the back end of a Soyuz vehicle on the assumption that this accelerated rendezvous profile is in the not-too-distant future incorporated in a Soyuz manned mission. It also would increase the ability to rapidly deliver a crew and supplies to the International Space Station in the event there would be a time-critical emergency on board the orbital outpost, and in the case of a situation that would prevent a redocking or a docking of a Soyuz vehicle to the space station, it would increase the time available for the replanning and re-rendezvous in a second attempt from just 1 day worth of margin to 2 days worth of margin. So everything has gone just by the book since the launch of the Progress 48 some 5 hours and 15 minutes ago from the Baikonur Cosmodrome in Kazakhstan. In the first 2.5 hours after launch, there were 4 major rendezvous burns of the Progress's engines called DV burns, delta velocity burns. Typically, in the first day of a normal 2-day rendezvous from the launch pad to the space station, there are DV1 and DV2, the first 2 of these rendezvous burns in the first 24 hours of the flight, followed by a 3rd DV or rendezvous burn in the day after launch, and a 4th DV burn 2 days after launch to place the vehicle in an automated rendezvous or terminal rendezvous capability. All 4 of these burns were packaged in the first 2.5 hours of this flight, and as a result, the accelerated rendezvous moved into its terminal phase just after 6 p.m. Central Time. Everything has gone extremely well. A series of small so-called impulse maneuvers or small thruster maneuvers to fine-tune the path of the Progress to the International Space Station were accomplished over the past hour and a half. The Core's automated rendezvous system was fully checked out. This is a different Core's system than the upgraded system that was tested on the old Progress 47 vehicle that rendezvoused and redocked with the International Space Station on Monday, following its undocking on over the weekend. The final undocking of the Progress 47 took place on Monday after a redocking over the weekend. That new upgraded core system was successfully checked out. The old Progress departed the Pirs docking compartment for good on Monday and has been placed in a safe distance away from the International Space Station for several weeks of engineering tests by Russian flight controllers. It will be deorbited and will burn up in the Earth's atmosphere in about 3 weeks. The 48 Progress, this new vehicle that was launched just a few hours ago from the Baikonur Cosmodrome, will arrive at the International Space Station for a docking just 34 minutes from now. It will remain docked to the Pirs docking compartment until Christmas Day.
Gennady, you can send the tour activate command.
Russian flight controllers instructing Expedition 32 Commander Gennady Padalka, who is inside the Zvezda service module, along with his cosmonaut colleague Yuri Malenchenko, to activate the Toru system, that is the telerobotically operated rendezvous system, a manual docking system that would be employed by Padalka and Malenchenko to fly the Progress 48 resupply craft in for a manual docking to the Pirs docking compartment. In the highly unlikely event there would be a failure of the Corps' rendezvous system. Again, the 48 Progress is equipped with the old version of the Corps system, not the new version that was successfully checked out on the 47 Progress vehicle that just departed the International Space Station on Monday for the final time. The International Space Station and Progress are currently flying 254 statute miles over the southeast corner of Australia, moving from northwest to southeast, about to make a swing just to the south of New Zealand and across the South Pacific.
Activating network. Have all the...
Right now, the 48 Progress vehicle is about 2 kilometers away from its docking to the International Space Station, closing at a rate of just under 6 meters per second. At the time of contact and capture at 8:24 p.m. Central Time, the Progress will be traveling just 1/10 of a meter per second in velocity.
Proceeding to the RUO and controller test. How do you copy? I copy. RUO test has been completed. No issues. Proceeding nominally to the route test.
The Progress vehicle once again was launched just about 5 hours and 20 minutes or so ago from the Baikonur Cosmodrome in Kazakhstan, and unlike its typical 2-day transit to the international outpost, this Progress was programmed and its onboard computers set up for an expedited, accelerated rendezvous of just 6 hours in duration to test once again the proof of concept that a quick rendezvous capability could be obtained and possibly applied to manned Soyuz vehicles in the future. No timetable has been given for the incorporation of this accelerated rendezvous for manned vehicles, although it is entirely likely that at least one more test of this fast rendezvous, the fast accelerated rendezvous capability, will be incorporated into the next Progress vehicle. That has not yet been confirmed, but all signs are pointing to at least one more test of this rendezvous profile.
Station is center, but not too clear. Gennady, if there's a need, you can toggle the lighting. Propose initial can be activated, then switch lighting, and then continue. Switch AGC mode and then continue. Yeah, we're going to do that, but a little bit later. Okay. We see braking 1.4 kilometers, 5.2 range rate.
The timeline from this point out calls for the Progress to reach the terminal phase of its rendezvous and to begin a fly-around of the International Space Station just after 8 p.m. Central Time, just a few minutes from now. It will complete that fly-around and do a roll maneuver to precisely align the forward docking probe at the forward end of the Progress spacecraft to the docking port on the Pirs docking compartment. Just a few minutes later, a period of station keeping will ensue while the Progress is about 175 meters or so away from the Pirs docking compartment. A final check of the orientation of the Progress vehicle to allow Russian flight controllers to ensure that we have a precise alignment between spacecraft and docking port on the Pirs. Once that takes place, the command will be issued for the Progress to begin the final phase of its rendezvous, with contact and capture anticipated at 8:24 p.m. Central Time. Within a few minutes, the hooks on the Progress vehicle will close around comparable hooks in the Piers docking compartment docking interface to form a hard mate between the two vehicles. The crew will conduct a series of leak checks over the course of the next few hours as they have adjusted their sleep period to accommodate tonight's activities. However, the hatch to the Progress resupply vehicle will not be opened until Thursday afternoon by Padalka and Malenchenko to begin unloading almost 3 tons of cargo from the craft. That includes almost 2,000 pounds of propellant, 110 pounds of oxygen and air, 925 pounds of water, and 2,817 pounds of dry cargo, which consists of maintenance hardware, resupply items, life support system items, and experiment equipment for the Expedition 32 crew on board the International Space Station. The Progress was rolled out to its launch pad at the Baikonur Cosmodrome in Kazakhstan on Monday. It was fueled for launch earlier this morning, Central Time, about 9:30 Central Time, and was prepared for its launch. It had to launch into a very narrow phase angle or corridor. In fact, 3 minutes before launch time earlier today, the International Space Station passed directly over the Baikonur Cosmodrome in Kazakhstan, and at the time of liftoff that you're looking at a replay of right now, the International Space Station was just 2,300 statute miles in front of the Progress 48 as its Soyuz booster lifted off from Site 1, Gagarin's launch pad at the Baikonur Cosmodrome. Once again, there were 4 major rendezvous maneuvers that were packed into the first 2 hours and 40 minutes of flight instead of being spread out over a 2.5-day period, as is the typical rendezvous profile, to accelerate the Progress's chase to catch the International Space Station, docking currently just 26.5 minutes from now. We are now just about 600 meters separating the Progress from the International Space Station. Its rate of closure has been reduced to just under 2 meters per second as the two spacecraft are about to become one. The Progress about to link up to the Piers docking compartment to complete this accelerated rendezvous.
650 and the rate 1.9. So we can see this stack very nicely, MRM1 and DC. Okay, copy. So its approach is from SM. 600 meters, 1.9 is the rate. Copy.
We're expecting to regain television capability through our tracking and data relay satellite system on the U.S. Ku-band communication system a short time from now. However, we will caution that television of the docking may be a bit spotty tonight just because of the geometry of the approach of the Progress to the Piers docking compartment relative to external cameras on the International Space Station. This docking will occur outside of Russian ground stations. If the docking occurs on time at 8:24 p.m. Central Time, it will occur over western Ecuador.
Скорость. 470 meters, 1.7 is the rate. Copy.
Once again, since its launch from the Baikonur Cosmodrome in Kazakhstan about 5 hours and 25 minutes ago, every single system on the Progress vehicle has functioned perfectly. Its core's automated rendezvous system, all of the engine firings perfectly programmed in a very clever and novel approach by the Russian engineers to enable a single-day launch-to-docking capability for this resupply craft. Again, this technique is being tested, at least on this flight, perhaps on an additional Progress flight later this year, to verify a proof of concept that may be incorporated into manned Soyuz launches to reduce the time that crews have to be confined to the rather cozy confines of a Soyuz spacecraft for 2 days plus.
Moscow station.
The Progress is now closing in on 300 meters away from the International Space Station. We're expecting the fly-around of the station to begin imminently.
No, not yet. I will do the adjustment. Okay, copy. Gennady Ivanovich? Yes, we have a good picture right now, so we won't use the AGC mode yet. 300 meters, 0.69 is the rate, but you are receiving the format, right? Yes, correct. Copy.
This is Mission Control Houston. You're looking at a view of the Progress 48, fresh off the launch pad of the Baikonur Cosmodrome in Kazakhstan, having accelerated through a compact series of rendezvous maneuvers, and now in the fly-around of the International Space Station. The fly-around has begun at a distance of just 290 meters away from the Pirs docking compartment. This fly-around will once again enable the Progress through its automated computer program to precisely align its forward docking probe with the Pirs docking port, enabling a period of just a few minutes of station keeping in which the approach will be zeroed out, enabling Russian flight controllers to assess its alignment to the Pirs docking compartment before the command is given for the final approach for docking.
260 meters, 0.44 is the rate. This station is very visible, very clear. We can see the DC, all modules. Okay, copy.
The Progress vehicle and the International Space Station now separated by just 250 meters, flying over the South Pacific at an altitude of 253 statute miles. Both spacecraft soon to enter an orbital sunset. And once again, if you look against the cloud-covered South Pacific Ocean, you can tell the Progress 48 vehicle. External cameras on the International Space Station zooming in. And an even better view now zoomed in by the communications and tracking officer here in Mission Control. A good view of the Progress 48. It took just under 9 minutes for the Progress to reach its preliminary orbit following its launch from the Baikonur Cosmodrome in Kazakhstan at 2:35 and 13 seconds p.m. Central Time on Wednesday. Once it arrived on orbit and separated from the third or upper stage of the Soyuz booster that sent it aloft, the Progress deployed its navigational antennas and its solar arrays and began a comprehensive checkout of all of its systems, conducted 4 major rendezvous burns in the first 2.5 hours of flight, and a series of subsequent mid-course correction burns to fine-tune its path to the International Space Station, now just 200 meters separating Progress from its destination.
Station keeping is...
And the visiting vehicle officer here in Mission Control reports that right on time, station keeping has begun. Once again, this will be a period of just a few minutes of station keeping to enable the Russian flight control team in Korolyov outside Moscow at the Russian Control Center to evaluate the alignment of the Progress's forward docking probe to the docking port on the Pirs docking compartment. This is an impressive series of operations by the Russian flight control team in Korolyov, executing tonight the second docking of a Progress vehicle in just several days here. The redocking of the Progress took place on Saturday night. The old Progress vehicle, it undocked for the final time on Monday, and now within 48 hours of that final undocking of the old Progress from Pirs, we have a brand new Progress vehicle on an expedited and accelerated rendezvous profile that's about to dock to Pirs and spend the next several months linked up to that docking port.
Yes, go ahead. Yes, go ahead. Please select the initial. Say again.
Вот эти три команды, БПС исходная.
So BPS initial, the first command, then Работа operation, the second one, and the third deactivate operation. Okay.
This view is from an external camera on the Progress vehicle, the engineering overlay that by now most of you are familiar with. In the lower left-hand corner, the 195 km shows just 195 meters actually separating the Progress from its docking port, closing at a null rate right now.
We have second approach.
And the visiting vehicle officer reports now that final approach has gotten underway a few minutes ahead of schedule. The Russian flight control team very happy with the alignment of this vehicle to the Pirs docking compartment.
Rate again, acceleration of 0.7, copy.
метров.
160 meters, 08 is the rate. You can see the target.
You can see right in the crosshairs of this target, or just to the right of the crosshairs, that is the Pirs docking compartment. Launched on a Russian booster back in 2001 to the International Space Station, now 11 years old. The Pirs is scheduled to be replaced by a new larger laboratory module that will also double as a docking port, scheduled for launch in late 2013.
Do you read?
Геннадий Иванович.
Gennady?
метров, 0,66 скорость.
110 meters, 067. Everything is stable and nominal. The target is practically in the center.
The Progress cruising in slightly ahead of schedule. Just 110 meters separating Progress from its docking destination. Once again, after contact and capture, there will be a period of just a few seconds to allow the relative motion between the two vehicles to dampen out before the forward docking probe on Progress is retracted to literally pull the Russian segment of the International Space Station flush with the Progress docking interface and form a hard mate. Hooks will begin to close on both sides of that docking interface, and leak checks then will be conducted by the Russian crew members on board the complex before they call it a night. The hatch to the Progress not scheduled to be open until Thursday afternoon.
70 метров.
70 meters, 0352
Мишень в центре.
is the rate. Target is in the center, and the crosshairs are matching. Everything is stable. Copy.
Just 70 meters now separating the two vehicles, closing at a rate of 0.3 meters per second. Everything functioning perfectly on the Progress 48. .60 meters separating the two spacecraft, everything looking normal. All systems on the Progress functioning by the book. No issues reported. This is an automated approach, as has every facet of this flight in the 5.5 hours that have transpired since its launch from the Baikonur Cosmodrome in Kazakhstan.
Геннадий Иванович,
Gennady,
Да.
go ahead.
на 30 метрах выдать команду
30 meters,
пояс исходного и работа.
please send the command prepares initial
На 30 метров.
and operation. Okay, when we are at 30 meters, we will send those two commands.
Правильно.
Copy. Affirmative.
Метров проходим 0,2 скорость.
50 meters, 0.2 is the rate.
Принято.
Copy.
Геннадий Иванович, и выбрать увод разрешен.
Gennady, and also please select
На 30 метрах.
breakaway is
Да, БПС исходная, работа, и вот разрешен выбор.
Работа, вот разрешен.
is enabled. Yes, we will do that. We will select a breakaway enabled, and we will also try to use AGC mode.
Progress 48 loaded with almost 3 tons of food, fuel, and supplies for the 6 crew members on board the International Space Station.
See the crosshairs.
3 Russians, 2 Americans, and a Japanese astronaut led by Commander Gennady Padalka, the first 3-time commander of the International Space Station. He and Yuri Malenchenko at the controls of the manual docking system.
Matching with the background.
They would take over manual flying of the Progress in the unlikely event the automated core system would incur a failure. However, the core's antennas have now been properly retracted. Everything in great shape as the Progress glides in for a docking which is now expected to be slightly ahead of schedule. Just about 30 meters separating the two craft. The Progress will disappear behind the Kibo module that you're seeing in the foreground of your picture.
And we're getting ready to send the command BPS and also the operation command. We have 30 meters. Okay, so I'm sending BPS initial, then operation, and also breakaway enabled. Copy. Can we use the AGC mode? Yes, you can.
.30 meters now separating the two spacecraft. Progress closing at a perfect rate of 1/10 of a meter per second. Once again, this unpiloted vehicle will stay docked to the Piers docking compartment until Christmas Day, when it will undock and make room for yet another craft. The next Progress vehicle, Progress 49, is scheduled to be launched from the Baikonur Cosmodrome on November 1st and docked to the aft port of the Zvezda service module, currently occupied by the Eduardo Amaldi automated transfer vehicle for the European Space Agency.
So the target is shifted a little bit to the right, but everything is within the limits. The vehicle is moving very steadily. Copy.
На базу R перешли.
So Baza Air,
Отведена.
we have now it is on AO.
Great views of the Progress 48, which just a few hours ago sat atop the third stage of a Soyuz booster on Gagarin's launch pad at the Baikonur Cosmodrome in Kazakhstan. Now about to complete an accelerated rendezvous and docking to the International Space Station.
17 метров проходим 0.
17 meters, 0.12.
Just 17 meters separating the two craft. Progress 48 and the International Space Station traveling from southwest to northeast across the Pacific Ocean west of South America.
Moving towards the center. Copy.
метров прошли.
15 meters, 013 is the rate. Copy. The target is in the center. Copy.
Вы визуально определяете дальность загона.
So you are defining the range visually, yes.
Визуально и по линейке.
Visually and also using the ruler. We have a special ruler. It's very convenient. Yes, I understand.
Подходим к дальности 10 метров.
Yes,
14 скорость.
10 meters now is the range and 0.14 is the rate. Copy.
And Progress now less than 10 meters away, standing by for contact and capture.
10 meters is already done. Copy.
метров, да.
We're at 8 meters now.
Скорость не более 0,1.
Not more than 0.1 is the rate.
7 метров дальность.
7 meters.
Устойчивый корабль.
The vehicle is stable. 6 meters is the range. Copy.
The docking target now aligned with the forward docking probe on Progress thanks to the Corps' automated rendezvous system, just 4 meters away.
The rate is about 0.1. Copy.
3 метра прошли.
3 meters. Copy.
Метр дальность.
1 meter
Ожидаем.
is the range. We are expecting the contact. Copy.
Есть касание.
Contact.
Docking confirmed
Copy.
at 8:18 p.m. Central Time.
Fine. Beautiful.
Docking confirmed. Progress 48 completes a 6-hour ride in the express lane from Baikonur to the International Space Station.
According to the procedure, okay. Copy. Will do.
Space station now in free drift, preventing any inadvertent thruster firings to allow the relative motion between the two vehicles to dampen out before the docking probe on Progress is retracted. Docking occurring 253 statute miles over the Pacific Ocean, just off the west coast of South America. So less than 6 hours ago, the unpiloted Progress 48 resupply ship sat enclosed, enshrouded at the top of the third stage of the Soyuz booster on the launch pad of the Baikonur Cosmodrome in Kazakhstan. And now, less than 6 hours later, is attached to the International Space Station. Hooks will be driving shortly to form a hard mate between Progress and the Piers docking compartment. Once again, docking occurring at 8:18 p.m. Central Time over the Pacific Ocean at an altitude of 253 statute miles off the west coast of South America. So with docking having been completed in a flawless fashion, we're standing by for the initiation of the retraction of the docking probe and the closing of hooks on both sides of the docking interface to form a hard mate.
Solovyev, here you are there. I am here. Go ahead, Vladimir Vasilyevich. So congratulations. The whole crew as well. So in 6 hours, almost 6 hours, it took us to dock the vehicle. So, yes, it's an achievement. Great. Yes, I agree. It's a dream of every cosmonaut after the launch, 5, 6 hours later to be on the station. We have already discussed that. If we use this system again, that will be fine. Yeah, it's new, it's just a start, and we have to move slowly, step by step. So the next variant we will suggest it for Soyuz vehicle. So how would you like that? In 6 hours to be on the station? Yes, that's what I'm telling you. It's the dream of every cosmonaut and astronaut to be at the station as soon as possible. In a warm environment with hot meals. Yes, correct. That would be great. And also, the good backup for storage for all kind of operations. Yes, correct. So it's actually very progressive step. Yes, we will have a few days as a backup. Okay, congratulations are again in order. Thanks a lot. Thanks a lot. We also congratulate you on the ground and thank you for our joint cooperation and your support. Good luck.
That conversation between the chief flight director for the Russian flight control team and Korolyov, Vladimir Solovyev, a veteran cosmonaut in his own right, and Expedition 32 commander Gennady Padalka, congratulating each other and verifying what we've been saying over the past several hours, that this test, the first ever single-day launched to docking scenario executed for the International Space Station, proved to be flawless. The Progress 48 executing all of its rendezvous burns, and the flight profile that was constructed by the Russian flight control team, capping off a rather impressive 10 days of operations in which the old Progress 47 resupply vehicle loaded with trash was undocked from the Piers docking compartment and redocked to test a new upgraded CORS automated rendezvous system that worked just fine on its second attempt at redocking before the Progress was cast off and undocked for the final time for engineering tests just a couple of days ago. This launch to docking scenario lasting less than 6 hours in duration may be retested once again to verify all of the engineering nuances of this technique in the next Progress, which is Progress 49, scheduled to be launched on November 1st from the Baikonur Cosmodrome. That has not yet been finalized or formally approved. The whole intent, as you heard in that exchange between Solovyev and Padalka, designed perhaps to be incorporated for manned Soyuz launches in the not-too-distant future to reduce the amount of time a crew has to spend confined to the cozy environment of the Soyuz vehicle in what has been a 2-day rendezvous from launch to docking. In fact, the next launch of a Soyuz vehicle in October will employ the standard 2-day rendezvous profile for Oleg Novitsky, Evgeny Tarelkin, and Kevin Ford when they are launched from the Baikonur Cosmodrome on October 15th, docking to the International Space Station on October 17th. But this technique, having been flawlessly executed in this scenario for the Progress 48, is going to be analyzed and perhaps may be incorporated in the not-too-distant future for a manned Soyuz vehicle, enabling a crew to reach the International Space Station in the same day after launch. So for those keeping score, the elapsed time from launch to docking was 5 hours and 43 minutes. In moderate traffic, it probably takes that long to drive from Houston to San Antonio or in that neighborhood. So a very impressive achievement for the single-day launch to docking accomplished by the Russian flight control team in bringing Progress 48 to its port at the Piers docking compartment. And now we have received confirmation that the hooks are closed. The Progress now hard-mated to the Piers docking compartment, enabling the Russian crew members on board the station, Gennady Padalka, Yuri Malenchenko, and Sergei Revin, to conduct leak checks that will lead to the opening of the hatch to the Progress resupply vehicle on Thursday afternoon.
Okay, so operation is deactivated, page 27. And I'm sending the command to deactivate manual control. How copy? Copy. I have sent the command. Okay, should I send on the command on the deactivation of TV? Yes, will do. Okay, so the deactivation of TV is complete. So activate the BPS initial. So now I send the deactivation and the transfer of commands. Okay, copy. So the transfer to the standby is complete, and I deactivate operation. How copy?
This is Mission Control Houston. Once again, Progress 48 flawlessly docking to the Piers docking compartment on the International Space Station,
and deactivate,
culminating an express trip of just 5 hours and 43 minutes from its launch pad at the Baikonur Cosmodrome in Kazakhstan, launch occurring at 2:35 p.m. Central Time on Wednesday, docking occurring at 8:18 p.m. Central Time as Progress 48 linked up to the Piers docking compartment 253 statute miles over the Pacific Ocean off the west coast of South America, completing a very impressive proof of concept of an accelerated rendezvous profile that may one day be used for manned Soyuz missions to the International Space Station.
TV is deactivated. The command has been sent. So the CAP transmitter is deactivated.
So with the docking having been completed, the crew on board the station, the Russian cosmonauts, in cleanup procedures right now to back out of their docking cue cards. Progress safely latched now to the Piers docking compartment. The hatch to the Progress resupply craft will be opened on Thursday afternoon by Padalka and Malenchenko, enabling them to begin unloading almost 3 tons of supplies for they and their expedition crew mates on board the International Outpost. With that, we'll wrap up our coverage of the launch and docking of the Progress 48 to the International Space Station. One programming note, we'll recap all of the day's activities and all of the activities of the crew members on board the International Space Station on Thursday on our ISS Update Commentary Hour, which will be broadcast on NASA television at 10 a.m. Central Time, 11 a.m. Eastern Time. With that, we'll call it a day. Thanks for tuning in. From the International Space Station Flight Control Room at the Johnson Space Center, this is Mission Control Houston.
This is Mission Control Houston. The International Space Station crew now has supply ships from 3 different nations at their doors and are syncing up their sleep shifts as they get ready to open the hatches on a new load of supplies. A new Russian cargo vehicle, the 48th Progress cargo ship, arrived at the space station's Piers docking compartment Wednesday night, just 6 hours after its launch from the Baikonur Cosmodrome in Kazakhstan. was the first ever same-day rendezvous flight profile. It's being tested for a potential use on future Soyuz missions. The Russian crew members and the American and Japanese trio have been on different sleep shifts since yesterday in order to support the arrival of the Progress vehicle on Wednesday evening. Flight engineers Joe Acaba, Sonny Williams, and Aki Hoshide have been awake since 2:30 a.m. Houston time on Wednesday. Acaba and Williams had their morning exercise sessions, while Hoshide set up equipment for the VO2 max experiment, and then conducted exercise while having his oxygen uptake measured in order to try to find out how it differs for a person on orbit as opposed to a person on Earth. Hoshide also had his weekly tag-up with the management of the Japan Aerospace Exploration Agency and conducted maintenance on the space station's waste hygiene compartment. Acaba filled out his morning with station maintenance and then worked with a vascular experiment, which is a Canadian experiment looking into the mechanisms responsible for changes in a person's blood pressure, particularly those changes that can occur in people on Earth as they age. Acaba spent time during his afternoon joining Hoshide on deploying portable breathing apparati around the space station. For Sonny Williams, her morning science work was with the BCAT, a physical sciences experiment into critical points of binary colloidal alloys. The results of that could lead to prolonged shelf life of everyday products, and long-term could lead to development of new materials for electronics and medicine. Williams had time in her afternoon for treadmill exercise, conducted today wearing a special set of markers that help biomechanical engineers see that the exercise is being done properly so that the crew members get the most out of the work that they do. Space Station Commander Gennady Podolka and flight engineers Sergei Revin and Yuri Malenchenko had a late wake-up call. It didn't come until 8 o'clock Houston time Wednesday morning. They're to begin making leak checks of the interface between the Progress vehicle and the Pirs docking compartment. Podolka and Malenchenko will work on opening the several sets of hatches between the two modules at about noon Central Time, while Revin will be in charge of the air sampling as those hatches are open. He'll also be seeing to other Russian systems maintenance on board the station. All 6 crew members due to be back on the same schedule for the Thursday afternoon planning conference, as well as the weekly tag-up with the NASA Astronaut Office. They all will be looking ahead to the schedule for Friday, which includes unloading of the Progress vehicle, plus Acaba and Williams, Acaba and Hoshide. They'll be training for robotic arm operations when they will be using the Canadarm2 as well as the Japanese robotic arm to remove an unpressurized cargo pallet from the H-2 transfer vehicle and move it onto the Kibo exposed facility. That activity on the schedule for the crew next week.
Here we are at Ellington Field, which is just down the road from NASA's Johnson Space Center and the place where we have our aircraft operations, including the landing strip where we conduct our zero-G gravity flights for tests of different science experiments and other things, including, as you can see, spacesuits, as with our third guest here. To tell us today about the spacesuits is we have Philip Hooper, who is a member of the crew survival team and one of the group that's working on the spacesuit we see here in front of us. So thanks so much for joining us, Philip.
You're welcome.
So this looks a little familiar, kind of like a shuttle launch and entry suit. Is that correct?
It should look very familiar to people. It's virtually the identical suit that we flew on shuttle. We took some things and made some architectural changes to it to change it from what we call a open loop system to a closed loop system. On the shuttle system, there was a pressure controller that would control the pressure of the suit, and as that vented, it would dump everything to the environment. The shuttle had a huge supply of consumables. That's something that with the modified ACES flying on Orion, it will not have those. They won't have those huge consumables to them. So we've taken it and made it a closed loop system where you have a hose that comes in and out, and all that air gets, as it's controlling the pressure by an onboard system, it takes that and washes the CO2 out that the individual in the suit is breathing.
But it's for use on Orion, which of course is the new vehicle that we're working on to take us eventually into deep space. So,
yes.
A little bit different requirements than the shuttle suit, but we're able to kind of make use of what we already have and save taxpayers some money.
Yeah, that's absolutely correct. The overwhelming majority of this suit is the hard goods, or the most expensive. We replace the soft goods on a periodic basis anyway, and so being a funds challenge time, and we looked at ways that we could leverage off our existing designs and make some simple modifications and fly a good suit, hopefully with some mobility changes and stuff that we're looking at making later.
So launch and entry suits, that's not what we conduct spacewalks in. It's not that kind of spacesuit, right? Tell us a little bit about what those do.
The launch and entry suits?
Well, and this suit as well. And how they're
this
similar.
suit is mainly meant for IVA capability. That's inside the cabin. Okay, on shuttle, it was actually made for a bailout. Here we're looking, because there aren't any EVA requirements that we have been identified yet. It would mainly be an IVA requirement, and we want to have some limited mobility to it, such in the event the cabin depressurizes, that they're able to do some basic things such as ingress the seat, and some minimal mobility requirements to climb around and be able to strap themselves into the seat.
Okay.
So,
but they wouldn't wear this all the time when they were inside, right?
They would wear it pre-launch and just in case of an emergency,
right.
where
most of the time they could just wear shirt sleeves.
Yes, that's correct.
But they would get this on if something happened unexpected, or when they were launching or coming back to Earth?
That's correct. Or if there was an emergency where they might have to, where a cabin depressurization occurred, where they would have to don it quickly and then get ingressed into the seat and strapped in a semi-safe manner.
So what does that mean that this suit has to do?
This suit basically protects you against the lower atmospheric pressure in event of a depressurization, because at a altitude that is very high or low in barometric pressure, your blood will actually begin to boil.
Which you want to
and
avoid.
that's what we're trying to prevent in this case with this suit.
So we say a lot when we're talking about the spacewalking spacesuits that they're kind of their own space vehicle. Is that true of a suit like this, or?
The spacewalking suits are a very complicated suit because of the mobility requirements. They have bearings in almost all of the joints, and this suit, because it was mainly meant to just protect you against a low pressure environment, it has some good mobility in the legs and the arms, and you can see the bearings here in the neck ring and the helmet. But it wasn't meant to do complex requirements. And now for Orion, we are looking at increasing with some of the joints, some increased mobility tasks, because there have been some scenarios identified where they might do a little bit more over and above than was the requirement for shuttle in terms of mobility. So.
But for the most part, they just need to be able to sit in a seat and reach all of their controls, things like that?
Get in the suit and hopefully make it a reasonably comfortable event, and do some minimal mobility events. Yes.
And that's what y'all are testing this week, I think.
Yes.
How well it moves.
Yes, that's correct.
Okay.
One of our main objectives was the seat ingress requirement that I explained to you, and that is one of the things that we verified, that you can in fact get in the seat. Once you're in the seat, it's challenged whether you could actually strap yourself in, but
we have a seat here behind us to show you what they have to get into, right? It's pretty narrow, and this is kind of, not as bulky as a spacewalking spacesuit, but not small either. So you have to.
That is actually the current baseline of the seat right now, so it's a very high-tech version of what we think it's going to look on Orion.
Okay. All right, well, thank you so much. I think we're going to have another chat with another team member later and see some of the footage from the zero gravity test that they conducted this week. So we'll talk to you a little bit later. We're back at Ellington. We talked earlier about the suit that they're testing this week, a modified what was called ACES suit for the Space Shuttle program that they're now getting ready for the Orion program. And here we have Dustin Gomert here to tell us a little bit about the tests that they're actually doing with that suit. So one of the things involves this seat, right?
That's right. This seat was essentially designed around the suit. We knew that that suit, or a very similar version of that suit, would ultimately be used in Orion. And so we built it around the suit, but what we did additional to that was we built it so that it's adjustable to fit people who range from heights of, say, 4'9" to 6.5 feet tall. And so there's a huge range of adjustability, but by doing that, to make the Orion operable, we had to put everyone so that they fit with basically the same eye point. So when they laid their head in there, they looked at this display no matter what height you are. Well, to do that, we make this seat, the seat pan that you actually sit in, adjustable up and down the axis of their body. Well, the testing we needed to do was show that if we were in orbit and had a depressed cabin contingency, well, the first thing we do is we get in our suit. And, well, obviously that's the most important thing. And then after that, you have to get into the seat to come home, because that's the next most important thing. Well, the suit gets large. It grows quite a bit around you as it inflates. So to ingress this seat in the stiff and large suit, we were testing different options for how to make this seat more maneuverable on orbit. So one of the things that we did was look at different levels of adjustability so that we could translate our bodies into the seat in the pressurized suit and buckle ourselves in for the ride home.
Okay, and I think actually we have some footage of that those tests taking place on the zero gravity flights that we can show you. But the idea is that there would be 4 of these seats in the Orion, correct?
That's correct. So this would actually be seat 2 of 4, the way it's set up with the displays above it, but you can imagine another seat directly to the left of it and then 2 more positioned directly below it. So there's a grid work of seats that are laid out in the vehicle, one mirroring this one exactly, and then if you can imagine the folks who are below it, their heads are actually below the feet of the pilot commander who are flying above them.
So it's, you know, the Orion's reasonably large for a spacecraft, but still a pretty small space. A lot of difficulty maneuvering around, especially when you've got the bulky suit on.
That's correct. A large spacecraft is still relatively compact compared to what we're used to in the free volume that we have the luxury of being in here. And when the suit inflates around the person, each person, you can imagine, expands to almost double their volume. And so it gets tight very quickly, and so we have to make the most creative use of the space as possible to allow them to ingress the seats for a safe trip home.
And I guess, you know, we can do that a lot here on the ground, but having it in the microgravity simulation is probably a big help.
It's a huge help for us, because one of the things we get in 1G environment, the Earth's gravity environment we're in right now, is we get the effects of stability. We can't spin out of control, we can't lose our grip and fly off. And so in the zero gravity environment, it gives us that real, true sense of how the suit will perform when we have that instability and we have to fight to put ourselves in the proper position and lay in the seat to get home.
Okay, and it's probably worthwhile to explain how we simulate that zero gravity. We get the suit and the subjects in an airplane, and they fly in parabolas.
That's correct.
So you get a few seconds of zero gravity floating as you go down, similar to how when you go down a hill on a roller coaster,
right?
Right?
So the plane will pull up at an extreme angle. During that time, the gravity is actually relatively intense. It's about 1.8 times what we're feeling, so you're very heavy during that period. But when it gets to the top, to the apex of that parabola, it dives down, and it dives at such a controlled rate that you fall inside the aircraft at the same rate the aircraft is diving, so you essentially float. Free falling, but you're floating inside the aircraft. It's very similar to what a zero-G environment is.
Okay. Well, and how did the test go this week?
It went very well. We had great luck in proving out the theories that we had on how the person in the suit would ingress the seat, and we learned quite a bit about the mobility of the suit for non-seated but translation type operations, for perhaps contingency tasks that we would look at in future scenarios and future missions.
Okay. Will you need to do these again before you're ready to fly? Or?
I think from what we learned, we'll probably do a few iterations of design work before we get there, but this gave us the capability to learn what the baseline performance of this suit is, relatively unmodified from its shuttle variant, and also give us an idea of what we need to do to tweak it to make it really perfect for the Orion capsule.
And I know you have some other tests that you'll be performing as the work progresses.
That's correct. We started in JSC in Building 9 in the Argos environment, adaptive response gravity offload simulator.
Right.
And so you essentially hang from your belly, very similar to Mission Impossible style.
Okay.
And you can float around in a frictionless environment. But what we don't have is the full degrees of freedom you get in true weightlessness. So we use that as a starting point to get to this environment, and then we used this environment to give us a feel for how realistic that was. That being a much more benign environment, we can test over and over again rapidly.
Right.
And we plan to use that for our development cycle, and then use the flight for some more of our validations of performance in a more high-tech or more realistic environment.
All right. Well, hopefully we'll see more of that coming up.
We hope so.
Thanks so much for talking with us,
Thank you.
Dustin. We'll go back now to Mission Control and live coverage of life in space. Thanks. Hi, welcome to Building 9 here at the Johnson Space Center, the Space Vehicle Mock-Up Facility. And we've actually got behind us a Space Vehicle Mock-Up, our Space Exploration Vehicle, one of our rovers, which is this week being used for the dry runs of the Research and Technology Studies Test, or RATS. And here to talk with us today, we have James Johnson, who is the test director for RATS. Thanks so much for coming and talking with us.
Well, thank you, Brandy. I appreciate it.
So what's going on this week?
Well, as you mentioned, it's a dry run. And so what we mean by dry run is really practice. Practice makes perfect for us. We're getting ready for our test, which is going to be towards the end of August. Our official testing actually starts August 20th, and we're going to run for 10 days straight. So what we're trying to do right now is exercise some of the communication systems, data systems, the big simulation, and the vehicle that's behind me. Trying to get all of that up and running, train the crew, and be all ready to go come the end of August. So that's what we're doing.
And let's back up a little bit. What is RATS exactly?
So RATS is Research and Technology Studies, as you mentioned, and what that does is we analyze both architectures, mission architectures, how you're going to conduct a space mission going to an asteroid, going onto Mars, going back to the moon, wherever we may go outside of low Earth orbit, and then the technology piece, and that's actually trying to mature and advance new and developing technologies. So we're actually hoping to do both coming up here later on this month.
And this is part of our analogs program, right? It's simulations here on the ground, right?
Exactly. Analogs is all about exercising real-time mission operations with new and developing technologies, so that way we can get a good understanding of how some of these technologies are going to perform when we actually go ahead and take them beyond low Earth orbit. Okay. We do that early in development, so that way there's fewer surprises when we actually get there.
Okay. And folks who watch NASA TV a lot may have seen fairly recently the NEMO mission down below the sea, another one of our analogs, and we also had one just last month in Hawaii doing some in situ resource utilization work. So we've got a lot of different things going on, but what we're trying to accomplish specifically with this year's RATS test?
So this year's RATS, there's two aspects that we're really taking a look at. The first is, again, that architecture piece. And what we're looking at there is where do we put crew members between some of the major elements for deep space exploration, okay? We have the multi-mission space exploration vehicle here. We also have what would be called the deep space habitat, and we are mocking that up with a workstation also here in Building 9 in another room. And we're trying to understand, how many crew do you want in each of those elements as you're actively exploring a surface. And in this case, it's actually an asteroid surface. We're looking at the surface of Itokawa.
Okay.
So.
And I guess, and we've had many RATS tests in the past. Usually, though, we have desert in front of the RATS, desert RATS.
Right.
This year, though, we're here in Houston at Johnson Space Center. Why is that?
Well, there are a few different reasons for it. What we really want to do is make sure we're testing in the best environment to get as much data as we possibly can for those future architectural scenarios. And the desert doesn't really lend itself well to an asteroid surface. That's a microgravity environment. So with the NEMO test, we ended up focusing a little bit more on the microgravity aspects. And for the actual exploration aspects, we found we can do a lot of that through simulation. And that's why we're here utilizing the simulation behind us.
Okay. And you mentioned, like you said, this the SEV, the Space Exploration Vehicle behind us is one of the ways, and we've got a few others. You mentioned the Deep Space Habitat. It all comes together and hopefully will help us figure out how we're going to send humans to an asteroid in the future?
Exactly. Yeah, we want to understand how we're going to do it. We want to understand the technologies that are going to take us there. So, the other piece is that technology studies, and one neat thing that we're doing at RATS this year is we're actually demonstrating some new generation fuel cell technologies. So we actually will have a fuel cell coming in here periodically and providing power to the space exploration vehicle. And then as they're providing that power, fuel cell is going to provide power. It also produces a lot of water in that process. And that water is going to get taken to another facility here on site to exercise another technology called Marco Polo, and that's a demonstration technology for electrolysis of water, breaking down the water, turn it into hydrogen and oxygen, assuming that that water was actually gathered through in situ resource utilization. Okay. So that way we're testing out a couple of different technology pieces while we're answering some of the questions of how we're going to explore an asteroid.
And hopefully all this comes together and you've got kind of a big piece of the exploration puzzle solved by the time we're ready to go, right?
Exactly. What we do is we call that the ops concept. And what we try to do is define how are you going to do those operations, how are you going to conduct that mission, so that way as you are developing your hardware, everybody is in lockstep with how you're going to develop the hardware, why you're developing it, what the core needs and goals and objectives are for that hardware. So that way when it's all built and ready to go, everybody's in full agreement, and we expect how that is going to behave when we take it out to low Earth orbit. Okay.
And you know, I think a lot of people are talking about the Curiosity landing that's coming up on Mars well, next week, at the beginning of next week. Do you think, you know, hopefully someday we'll be sending humans to follow it. Do you think these are lessons that we'll be able to use when it's time for that?
Oh, certainly. You know, the question of where do you place crew between some of the deep space elements is one that is not unique just to asteroid exploration. It applies to Mars, it applies to lunar exploration, any destination we go. How do you really handle those types of operations? Where do you place the crew? How are they best utilized? Those questions are going to apply even when we go to Mars. And so hopefully the lessons that we learn here, we'll be able to go ahead and apply when we actually set foot on Mars.
Okay, maybe we'll come back and talk more about that when that happens too.
I hope I can be here for that.
Absolutely. Hi, welcome back to Building 9, the Space Vehicle Mock-Up Facility. We're back with the RATS Group Research and Technology Studies, and this time we're talking with Stephen Rader, who is the data manager for analogs. Analogs are ways that we simulate missions here on the ground. And in this case, we're doing, again, an asteroid simulation, and he is working on a lot of different aspects of that. Why don't you tell us a little bit about what all you do?
Okay. Well, I work a lot with the integration of the systems, making sure that all of these different projects that come together for analogs, that their software can talk, that all of their systems can talk on our networks, and that they will all work with opposite systems like the control centers and our little control workstations we have all around here. And then I make sure that we can get all those systems to work over the delayed comm. So what we actually have here is communications that are 50-second delayed one way. So to the asteroid would be one-way light time, and back would be 50 seconds as well. So for me to have a conversation with you, it would take 50 seconds for you to hear me, and then 50 more seconds for me to hear your response. So a minute and a half for any round trip conversations we have.
Should we demonstrate that for us? Maybe
Might
not,
be kind of boring.
Okay, well, tell us a little bit about why we're delaying the communications at all.
Right. Sure, well, like I said, the light time, the time it takes light to travel, which is the time it takes our radio signals to travel, increases as we go out from Earth. And so, for instance, Curiosity is going to be landing here in a few weeks. It's on Mars, and at this point in its orbit, it's about 14 minutes for light to travel all the way out to Mars from the Earth. And so for them, it takes 14 minutes for a command to go to that vehicle, and it takes another 14 minutes for data to come back. And so we're practicing for an asteroid that's not quite that far out, but still significantly far out. The moon is about 4 seconds. And so because we're sending crews, we have an additional dynamic of humans in the loop, and those humans are, for the most part, used to a conversation with the ground control, mission control. And so we're trying to develop new ways to communicate and to understand how much autonomy they need, what their roles are versus the ground's role, and then when they do have interactions, how do we best do that? So a good example of that would be texting. We actually don't use texting currently very much on space station because we can have those real-time conversations. But we've started in the analogs testing using texting as a way to communicate better, because people are really used to that paradigm of using asynchronous messaging, or messages that get there not when you're expecting them, and you read them a little later and then you respond, and how that message flow works and how that works with operations.
And you've done this a few times now with, I guess, maybe Deserats last year, and certainly the Nemo mission this year.
Yeah, and then the Resolve payloads as well that we've been doing with the lander. So all of these analogs, and they all kind of converge towards answering some of those questions and helping us develop the right tools to deal with these situations.
And it sounds like a small thing, you know, you just wait a few minutes and you get your answer, but I mean, it's a big deal, something we have to figure out before we go to, say, Mars, right?
It is, yeah, absolutely, because it changes depending on what you're doing, how important that thing is, how off-nominal, in other words, if there's a problem, how long it takes something bad to happen. So we call it time to effect. If there's a valve you turn and start hearing a hissing noise, is that going to affect me in a minute or 5 minutes? And
do you have the 14-minute?
Right, do I have time to actually ask a question and get an answer before that bad thing happens? So you kind of have to think through all of that in terms of what you train crews for, but also the tool set that you provide them. We did some simulations on Nemo where we were using the crews, and we were using 5-minute and 10-minute delays where we had emergencies. And during those emergencies, what we found is if we weren't careful, the ground would acknowledge a message from the crew and say, yeah, we heard that, now do this. By the time the crew got that direction, their situation had changed significantly, and that was actually the wrong direction to give them at that point. And so a better understanding of the context of when somebody says something and why is tools we're working on how to facilitate that, if that makes sense.
Right. So do you feel like we're making good progress and we're going to learn a lot that's going to help us in the future?
Absolutely. We're working on several mitigation techniques, several studies to understand the impacts, and those we're actually starting to meet together with all of the different analogs to really understand that. And then some of that will be used in our testing, our new analog that we'll be doing, iStar, which will actually have crew members on the space station using delayed comm back to Earth in a more operational scenario.
Right, so it just keeps getting more and more realistic, right?
Right.
All right. Well,
and we use these to try to do that at a low cost.
Right now, NASA's Curiosity rover is closing in on Mars. After 8 months of hurtling through space, it is set to land on the red planet in less than 3 days. The U.S. Space Agency is bracing for a bumpy ride. Its explanation of the landing, it kind of feels like a movie trailer. Let's check it out.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0, in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
Well, gripping stuff there, but the odds are not on NASA's side. The red planet has a track record of rough landings. Roughly 60% of missions to Mars have failed, and Curiosity cannot simply land on the planet. It will take a supersonic parachute, a retro rocket pack, and a long tether to set the rover down gently. So, if Curiosity makes it, what will it do? Well, it's considered the first roving lab ever to be sent to another planet, and it's looking for signs that life existed on Mars. It has a high-tech toolkit with cameras, a robotic arm, a laser. It can also drill rocks and sniff out organic materials like carbon, the building block of life. Now, it is much bigger than the previous rovers, about the size of a small car, like a Mini Cooper. It's also 4 times heavier than other rovers. Now, it runs on a nuclear-powered battery that should last a full Mars year, or about 687 Earth days. Now, scientists are hoping that it could run for much longer. And NASA Administrator Charles Bolden tells us more about the mission.
If you can imagine going into the Grand Canyon, where we can look at the history of Earth, really, in that area as we look at various strata. That's what landing in the crater allows us to do, and it's actually going to climb the mountain, so it will look across the geologic history of the planet Mars in the 2 years that it's there. It's a harrowing experience. It's, as they say, 7 minutes of terror, but that's why we are NASA, because we like to do things like that. We love risky things, but we're confident.
Now, here's hoping that luck is on NASA's side. And that is Newsstream, but the news continues at CNN. World Business Today is next.
This is the #1 international news brand. This is CNN.
Well, good morning. I'm Bob Cabana, the director here at the Kennedy Space Center. It's my pleasure to welcome you here today for this announcement. As we celebrate the first 50 years of the Kennedy Space Center this year, we embark on a new journey taking us forward to the next 50 years of exploring space with the announcement of the companies selected for the next phase of development in our Commercial Crew Program. NASA will use the Commercial Crew Program to take our astronauts to the International Space Station later this decade. We are working to transform the center to support a new era of space exploration, modifying and upgrading our facilities for NASA's Space Launch System. The Orion spacecraft is here right now, and the team is processing it for its first flight in 2014. The KSC team has the human capital expertise, unique facilities, and specialized equipment to propel the agency into the next phase of space exploration. And a Commercial Crew Program is a key part of that. It's my pleasure now to turn the stage over to our administrator, Charlie Bolden, for more details on this historic milestone. Charlie?
Thanks very much, Bob. I want to join Bob and the entire KSC team in celebrating the 50th anniversary of KSC, first of all, and just the remarkable contributions of the entire Space Coast to America's leadership in space exploration. From the exhilarating days of Mercury, Gemini, and Apollo to the unprecedented 30-year history of Space Shuttle, the road to space has always and always will lead through the great state of Florida. In fact, the Kennedy Space Center is now the launch pad for the next big leap in America's space program, our Commercial Crew Program. This program is a top priority of the Obama administration, and you'll hear from Program Manager Ed Mango shortly. 2 years ago, right here at Kennedy, the President set a goal of sending humans farther into space than we've ever been, to an asteroid in 2025 and Mars in the 2030s. A bipartisan consensus was reached in Washington that the best way to do that was for NASA to acquire services from commercial companies to deliver cargo and crew to the International Space Station. That allows us to concentrate on building America's next generation space exploration system, the Orion spacecraft and the Space Launch System, the vehicle and rocket that will take American astronauts farther into space than any spacecraft developed for human spaceflight has flown in the 40 years since our astronauts returned from the moon. This dual-track exploration strategy is producing tangible results, and the teams here in Florida and across the nation are making steady progress. Exactly 1 month ago, on July 2nd, the first space-bound Orion spacecraft arrived at Kennedy, and as Bob said, is now undergoing final construction and integration in preparations for its initial test flight in 2014. And I'll remind you, that's less than 2 years from now. This work is expected to support at least 350 Space Coast jobs. The mobile launcher, which will serve as the launch platform for the SLS and which I just had the privilege of touring, will soon be ready to support our deep space exploration efforts. The President has fought to invest close to $1.4 billion in NASA's 21st Century Space Launch Complex and exploration ground systems. This investment will help us upgrade Kennedy's shuttle-era facilities to support multiple users and make this a more flexible launch facility for the future. The crawler transporters that have carried space shuttles and Apollo Saturn V rockets to their launch pads are being upgraded to support the next generation of spacecraft and launch vehicles that will lift off from Kennedy. Last year, Boeing announced they would be taking over one of our former orbiter processing facilities to work on their crew capsule and indicated they would be creating 500 jobs in the process. Recently, Sierra Nevada Corporation successfully completed a captive carry test of its full-scale Dream Chaser orbital crew vehicle, as well as a test of the vehicle's nose landing gear. They have also announced interest in establishing a presence here on the Space Coast, adding to the growing number of commercial companies who find this area an attractive place to do business. In May, SpaceX became the first private company to reach the International Space Station and return its Dragon capsule safely back to Earth, launching right here from Florida and the Space Coast. Our commercial crew and cargo efforts are based on a simple but powerful principle. By investing in American companies and American ingenuity, we're spurring free market competition to give taxpayers more bang for the buck, while enabling NASA to do what we do best, reach for the heavens. We're also making important progress toward ending the outsourcing of American aerospace jobs and bringing them right back here to Florida and other states all across this country. Our commercial crew program has been carefully managed in stages. In 2010, you may remember, during the first phase of our commercial crew initiatives, NASA entered into funded Space Act agreements with 5 companies to aid in the innovation and development of space transportation subsystem designs and concepts. Those companies were Blue Origin, Boeing, Paragon Space Development Corporation, Sierra Nevada Corporation, and United Launch Alliance. In 2011, during the second phase, we entered into funded Space Act agreements with 4 companies for the continued development of commercial rockets and spacecraft. Those companies were Blue Origin, Boeing, Sierra Nevada, and Space Exploration Technologies, or SpaceX. Today, we're announcing another critical step toward launching our astronauts from U.S. soil on space systems built by American companies. We've selected 3 companies to develop crew transportation capabilities as a fully integrated system and keep us on track to end the outsourcing of our human spaceflight program. These companies are Sierra Nevada Corporation, Space Exploration Technologies, and the Boeing Company. This is a diverse and dynamic mix of companies, each with unique experiences and proven track records in the aerospace industry. By keeping these 3 companies in the mix, we not only ensure competition, which is good for the taxpayers, but we're also guaranteeing that we never find ourselves in the situation we're in today, dependent on a sole provider to get our crews to space. For the next 21 months, these partners will perform tests and complete designs. Through this initiative, NASA will help the private sector design and develop the human spaceflight capability that could ultimately lead to the availability of human spaceflight services for both government and commercial customers. We'll also help support the creation of high-paying technology jobs here in Florida and across the country. The ultimate goal of our commercial crew space program is to bring human spaceflight launches right back here to American soil and end the outsourcing of these important jobs. Our U.S. industry partners will help us achieve safe, reliable, and cost-effective access to and from the International Space Station and other destinations of low Earth orbit. Before NASA begins using a commercially developed system to transport our astronauts to and from the ISS, the system must be certified as meeting all of NASA's safety requirements through an entire mission cycle. Certification of commercial systems for NASA transportation missions will be pursued in a future separate phase under the commercial crew program. The innovative spacecraft and rockets proposed by NASA's industry partners will also spur technological innovation and serve as engines of economic growth here in Florida and throughout the nation. Now, let me ask our commercial crew program manager, Ed Mango, to say a few words and give you a little bit more detail than I gave you. Ed?
Thank you, Mr. Bolden. First of all, I want to say thank you. My team and I are extremely excited and ready to go do this. We're ready to continue our partnership with industry and between industry and NASA in new and innovative ways. I am very confident in the ability and capability of our 3 partners under ICAP. I believe that we can make great progress with these 3 partners. What is ICAP? ICAP stands for Commercial Crew Integrated Capability. It is a capability that includes the spacecraft, the launch vehicle, the ground operations, as well as the flight operations. It's an entire mission cycle and doing the design work for that entire mission cycle. So we call it CC ICAP for short. ICAP is also being run under a Space Act agreement approach that NASA has been able to employ. And what that means to the taxpayer is NASA is not paying 100% of this development cost. We are sharing these costs through a partnership, through NASA and the individual partners. So they are also bringing money to the table. This is a way of leading, this is a way of allowing the United States to lead in the development of new space systems that are human capable, and then taking those systems for commercial purposes as well as for NASA purposes in the future. As Mr. Bolton said, there are three awards. The first is to Sierra Nevada Corporation. Sierra Nevada is going to be getting $212 million if they meet all their milestones. And under the SAA approach, milestones are paid once performance is done. So it's a paid-for-performance kind of approach. It's, again, very good for the taxpayers and very good for NASA. If they meet all the milestones, they can get up to $212.5 million. They've been a very strong partner under CCDEV-2, and they've been a partner during that period of time, in which they have completed their preliminary design review, and now they're working on their engineering test article, which is a test article of their Dream Chaser, full scale, they're going to use for approach and landing tests. We are very excited to continue our work with Sierra Nevada. Our second partner is SpaceX. SpaceX will be receiving $440 million as they complete their milestones throughout the base period of of ICAP. As you know, SpaceX is a very progressive partner. We like the way they think differently, and it's encouraging my team to think differently as we work with them. They too have been evolving through CCDEV-2. They take their design for cargo, which they flew just a couple months ago, and taking that to evolve it into a crewed capability. So they're working on their propulsion systems as well as working on their crew interface systems. And that has gone very well over the last year or so, and we want to continue to work with them very closely. The third partner is Boeing. Boeing will receive $460 million over the course of all the milestones if they meet them. They also are a very sound partner through CCDEV-2. During CCDEV-2, they completed a preliminary design review for their spacecraft and also completed a software review, preliminary design review, for their software. Again, a very hard challenge, and they met those challenges under CCDEV-2. They also are developing their propulsion system for their abort and their landing system when they land on the ground. All three of these were CCDEV-2 partners, and we look forward to working with them again in ICAP. You might ask, what does NASA bring to the table in this commercial partnership? Well, besides the taxpayer money that we will diligently manage, we also bring a team of engineers. We call it a partner integration team, or for short, a PIT crew. This particular PIT crew we have for each team. And this crew is made up of engineers, a lot from right here at the Kennedy Space Center, and also from the Johnson Space Center and many of the other NASA centers. They're NASA engineers. They're NASA safety engineers. They're NASA operations folks, both in the flight regime as well as in the ground regime. We put all these together in this PIT crew. They're going to work very closely with these partners. We bring our expertise, our 50 years of human spaceflight experience to the table, not to tell the partner what to do, but to tell them what we have learned over our 50 years and to help them in their design and help them in their risk management trade systems. My team is highly motivated to go do this, and you need a team that I was able to handpick so that these folks that are on these PIT crews can work in a very innovative way, can do things differently than what we've done in the past, and still try to make it as safe as possible and meet our requirements in the long run and meet the company's requirements in the short run. A bit later this morning, about 10:45 Eastern, there will be a teleconference in which we'll talk a little bit more about the details of the agreements and our partners at that time. You know, before I end, I'd like to take a step back and think about another time in history when the world changed. And that was back in 1927. In 1927, the only way to get across the Atlantic Ocean was through ocean liners. Charles Lindbergh took the courage to figure out a way to fly across the Atlantic Ocean nonstop. And that was, as many people call it, a Lindbergh moment, because it made the world smaller. It made the world capable of doing new and different and innovative things. And there's been many Lindbergh moments since that time. But today, the Commercial Crew Program and our industry partners are on the threshold of setting a new set of Lindbergh moments. Not just to cross the Atlantic, but actually to make the world smaller, the planet smaller, and to help commercial industry. Thank you. I think we're now opening it up for questions.
Good morning, James Dean from Florida Today. Possibly for Mr. Mango, just wondered if you could discuss a little bit more why this combination of three ultimately was selected in terms of it giving you a diversity of different types of spacecraft, a couple launch vehicles, of course. Also, how many proposals did you select from?
You see, NASA uses a very strict process for procurement. And so in that process, there's many proposals that come in that are evaluated. In this particular case, and you'll hear a lot more about this in the telecon, so you might want to, I encourage you to ask the question again. But the portfolio that was selected, as you said, is really all about diversity. Diversity of launch vehicles, diversity of spacecraft, and an ability to actually move through these milestones with high confidence that we can meet those milestones. That's how as a program, we don't make the selections, we implement the selections. When I look at this selection base, I look at it as a capability of diversity, and therefore we will not only have diversity in systems, but also redundancy and competition as we move forward.
Good morning. Julian Leak with America Space. This one's for Charlie, I believe. During the CC Dev 2, Blue Origin was awarded $22 million. Did they submit a program for CCIP?
Well, yeah, I'm going to let you ask that question in the next brief. And I will tell you, I was not privy to know how many companies submitted, who submitted, and I did not want to know. And I think, when you talk about the integrity of the process, I was briefed by Bill Gerstenmaier day before yesterday on what was going to happen. I knew what the process was because we had gone over that over and over and over. The Office of General Counsel, our procurement office, everybody was involved in this. So I don't know, whether they submitted or not, to be quite honest. I do know who the three winners were, so know that. Okay, but I would ask Bill Gerstenmaier that question. I think he can answer it.
Yes, sir. Chris Haber with Terrasanga Press. Are you going to, is Sierra Nevada planning on using any KSC facilities?
I'm going to let Bob address it because he talks to people all the time.
Actually, we have a Space Act agreement with Sierra Nevada, and eventually they do plan to use our facilities. We're working with them on what will be when. Not too long ago, Sierra Nevada was here, and they had a jobs conference, if you will, and we're doing hiring from the excellent workforce that we have here at the Cape. So it's my great hope that, yes, in the future, if they move forward and ultimately are selected to fly a cruise to the International Space Station, they'll be doing operations here at the Cape.
And if I could follow that up, do you know about how many jobs are being created here in Florida by them, and if they're using any of the retired shuttle force?
I don't have that number.
Thank you.
Colonel Cabana, just asking a similar question a little bit more broadly. We're just over a year past the last shuttle flight. Could you just address, where KSC as a center stands now, and how these announcements might impact the local workforce and sort of the center's progression in its transition?
Absolutely, James. When I look back on where we were a year ago and where we are now, we have just made tremendous progress. I wish I could get everybody out to see all the changes that are happening here at the Kennedy Space Center. In a lot of areas, you can't even see them all. They're down in the bowels of the pad, within the MCC, Launch Control Center. It's everywhere. And, the team, I think we really have turned a corner. We're reaching stability, and we're looking to hire as we move forward. Having the Orion vehicle here in the ONC High Bay now being built for its first flight in 2014. I mean, this is the first time we've built human spacecraft here at the Kennedy Space Center in excellent partnership with the state of Florida. That's outstanding. The progress that has been made on the launch facilities out at the pad, in the VAB, we're starting work there now. The transporter, crawler transporter number 2 is being totally refurbished to handle a heavier weight and to have another 20-year life on it. And the team's doing a great job there. It's just multiple projects like this. And I think getting to this next step in commercial crew, I mean, these two programs, I've said it before, I'll say it again, they're not mutually exclusive. They're extremely compatible, having a commercial capability along with NASA's exploration capability. This is our future, and we really do want to transform KSC into that 21st century launch complex of the future. We want to take what was science fiction and make it fact, and we're moving to make that happen.
I think possibly again for Mr. Mango, could you just explain a little bit the half award? Will that company accomplish half as much, or do they benefit from sharing a launch vehicle with one of the other competitors, or what is the difference between a full and half award?
See, again, I would ask you to ask that question in the next briefing because you'll see a lot more of the details. I guess my quick answer is no one has a full award or a half award. We negotiated with these partners how much work we can get done in 21 months that seemed reasonable to us and fit into an overall budget profile. So that's how we figured out the partnership as a portfolio.
Okay, there's no more questions. That concludes our briefing. Thank you.
Thank you all very much. Thanks for coming out.
Thank you.
This is Mission Control Houston. The International Space Station's Expedition 32 crew is wrapping up a week dominated by the comings and goings of cargo ships while they've been keeping up a strong pace of science operations. As the six crew members finished their first 3 weeks as a group on orbit. Saturday, July 28th, the crew opened the hatch on the H-2 transfer vehicle, HTV number 3, which had arrived at the space station the previous day, and started unloading tons of supplies. They, in fact, worked so much on that they got days ahead of the scheduled timeline. That evening, they monitored the redocking of a Progress cargo ship, which was testing out an enhanced version of the automated rendezvous and docking system, which worked just fine after Russian specialists raised the temperature inside that module. Over the weekend and even on Monday, flight engineers Joe Akaba, Sonny Williams, and Aki Hoshide spent a lot of time unloading the material inside that Japanese cargo ship. In the meantime, Commander Gennady Podolka, flight engineer Sergei Revin, and flight engineer Yuri Malenchenko monitored the final departure of 47P. In between times, Aki Hoshide installed he prepared the Solution Crystallization Observation Facility for a JAXA biotechnology investigation, which is aimed at refining our understanding of the mechanisms that drive the growth of crystals in microgravity. Akaba and Williams joined him for body mass measurements and ultrasound examinations. Williams also fed the spiders that are part of the YouTube Space Lab experiment that was delivered on HTV. That is a suite of 2 experiments that were developed by high school students and were selected by proposals that were delivered via YouTube. On Tuesday, the crew took readings for several life sciences investigations and started work with the Advanced Colloids experiment, which will examine materials that contain small colloidal particles to learn more about how those particles behave in microgravity. Williams also took time to talk to a radio station in Woods Hole, Massachusetts, her home state, and to Dr. Sanjay Gupta on CNN about the progress of her mission so far and plans for the future, and finished up the day with more body mass measurements. Podolka and Malenchenko had a refresher course in the operation of the Toru. That is the manual backup docking system in the Russian segment of the station that is used in case the automated docking system fails. But they were testing out Toru in advance of another imminent arrival. Wednesday saw, for the first time ever, the launch and docking of a Russian cargo ship on the same day. 48 Progress made the trip from the Baikonur Cosmodrome to the space station docking port in just 4 orbits of the Earth, instead of the usual 34 orbits. This was a test of a new flight profile that could save future human crews a lot of hours spent inside the cramped Soyuz vehicle on the normal 2-day transit to the space station. Earlier in that day, Joe Akaba set up and performed operations with a capillary flow experiment, which is a fluid physics investigation to learn how fluids behave in microgravity. Hoshide set up the ultrasound equipment for the integrated cardiovascular experiment, and then assisted Akaba in gathering data for the integrated experiment to quantify any atrophy of the heart muscle due to the absence of gravity. On Thursday afternoon, the Russian crew opened the hatches to 48P and started unloading it, and all crew members took part in routine station maintenance. Akaba worked with what is known as the vascular experiment. That's a Canadian investigation looking into the mechanisms that are responsible for changes in blood pressure, and particularly those that parallel changes that occur in people on Earth as they age. The crew members have been working in split shifts due to the Progress operations, but the whole expedition crew got their schedules synced up for Friday, which featured Progress unloading, Joe Akaba and Aki Hoshide training for robotic arm operations that are coming up next Monday, when they will fly the Japan robotic arm to receive a handoff from Canadarm2. The handoff item will be an unpressurized cargo pallet that ground controllers will extract from the HTV. The station crew members will move that pallet over to the Kibo Exposed facility on Monday, and to kick off even more groundbreaking science operations on board the world's orbiting laboratory.
Spannendes Thema. Grüne Männchen sind bisher noch nicht gesichtet worden, aber die Sonde Curiosity, also zur deutschen Neugierde, ist ja auch gerade erst auf dem Mars gelandet.
Ja, und wer weiß, was da noch gefunden wird in den nächsten Tagen und Wochen. Erst einmal herzlich willkommen, liebe Zuschauer, zu unserem News-Spezial.
Ja, es war ein Riesenjubel da bei der NASA im Kontrollzentrum im kalifornischen Pasadena. Denn das komplizierte Landemanöver auf dem Mars, es hat geklappt.
Now confirmed. We're safe on Mars.
Minutenlanger Jubel im NASA-Kontrollzentrum Pasadena in Kalifornien. Das Team liegt sich in den Armen, als klar ist, diese Landung ist geglückt. Der Mars-Rover mit dem Namen Curiosity hat sicher auf unserem Nachbarplaneten aufgesetzt und, was noch viel wichtiger ist, er ist voll funktionstüchtig. Die Zentrale bekommt sofort ein Signal des Roboters. Und dann das Unglaubliche. Schon wenige Minuten nach der Landung erreichen die ersten Bilder, die Curiosity von der Oberfläche des Mars aufnimmt, die Erde. Die Bodenkamera zeigt den Staub, der durch die Landung aufgewühlt wurde, und ein Bein von Curiosity. Ein anderes Bild, aufgenommen von der Kamera, die an einem Kranarm montiert ist, zeigt den Schatten des Mars-Rovers. Das Team kann es kaum glauben. Jetzt, wo wir das geschafft haben, sind wir so gespannt auf die Entdeckungen, die die Mission machen wird. Und wir freuen uns schon darauf, noch mehr Einsätze auf dem Mars zu machen und auf anderen Planeten. Das ist wirklich eine ganz schön mächtige Sache, die wir hier machen. Die Landung ist ganz nach Plan gelaufen. In genau 7 Minuten wurde Curiosity, wie in dieser Animation vorausgeplant, von fast 21.000 Kilometern pro Stunde auf 0 runtergebremst. Der Fallschirm öffnete sich, das Hitzeschild fiel ab und die Rückstoßraketen zündeten. Pünktlich um 7:31 Uhr unserer Zeit berührte der Roboter die Oberfläche des Mars. Für diese Meisterlandung kommen Lob und Gratulationen auch von den Kollegen aus Deutschland.
Wenn man sich überlegt, dass der Mars 250 Millionen Kilometer momentan von der Erde entfernt ist und dass man den Landeort innerhalb weniger Meter getroffen hat und auch fast zu der vorhergesehenen Zeit mit ein paar Sekunden Abweichung, dann ist das eigentlich unglaublich und kommt genau diesem Vergleich von hier ein Fußball nach Australien in ein kleines Tor zu schieben wahrscheinlich am nächsten.
Vor der Landung war die Anspannung beim Team groß. Schließlich sind gerade mal 6 der insgesamt 14 Landungen in der Vergangenheit geglückt. Mit der 1,9 Milliarden Euro teuren Mission ist nun der modernste und technisch am besten ausgestattete Mars-Rover am Ziel seiner Reise angekommen. Das Spektakel wurde auch in Deutschland live beobachtet. An der Universität in Kiel sind etwa 500 Besucher beim Public Viewing gewesen. Das Interesse ist hier natürlich besonders groß. Schließlich haben Forscher der Kieler Universität Strahlenmessgeräte an Bord der Curiosity. Damit sind die Kieler Forscher direkt an der Mission beteiligt. 2 Jahre lang soll Curiosity nun auf dem Mars bleiben und letztendlich die Fragen aller Fragen beantworten. Hat es Leben auf dem Mars gegeben und ist ein Leben auf dem roten Planeten auch für uns möglich? Curiosity hat mit der Arbeit begonnen. Jetzt dürfen sich die Forscher auf viel Material freuen.
Und in unserem Berliner Studio ist jetzt der Planetenforscher Professor Ralf Jaumann vom Deutschen Zentrum für Luft- und Raumfahrt. Herr Professor Jaumann, guten Tag. Wie wahrscheinlich ist es denn, dass die Sonde wirklich Spuren von Leben auf dem Mars findet oder wenigstens Hinweise auf lebensfreundliche Bedingungen?
Guten Tag. Die Wahrscheinlichkeit ist natürlich schwer einzuschätzen, weil wir nicht richtig wissen, ob es wirklich Leben auf dem Mars gegeben hat. Curiosity selber kann auch das Leben, das richtige Leben gar nicht nachweisen, aber eben die Spuren. Und Spuren heißt chemische Zusammensetzungen, chemische Verbindungen, die mit Kohlenstoff, aus Kohlenstoff bestehen, vielleicht sogar bis in die Richtung von Aminosäuren. Und Curiosity ist das erste Labor, das wir auf dem Mars haben, das in der Lage ist, solche Untersuchungen durchzuführen, einigermaßen vernünftig durchzuführen. Das heißt so, dass man am Schluss sagen kann, es gibt die Spuren oder es gibt sie nicht.
Jetzt ist Curiosity erstmal gut gelandet. Wie geht es jetzt weiter? Wird sie buddeln und graben auf der Marsoberfläche?
Also erstmal wird man jetzt natürlich alles überprüfen und es wird noch ein bisschen dauern, bis er losfährt. Dann wird man erstmal das Gelände beobachten, aufnehmen und vermessen. Denn es ist immer noch so, dass man für ein Signal zum Mars 14 Minuten braucht. Das heißt, Curiosity muss sehr, sehr viel allein können und dafür muss man natürlich vorher genau den Weg aussuchen, den er fahren soll. Und dann werden natürlich alle Instrumente erstmal getestet, haben die Landung richtig gut überlebt und sind die funktionsfähig. Und dann wird man sich auf den Weg machen. Man ist natürlich an der, soll man sagen, flachsten Stelle in dieser Gegend gelandet und dort ist zwar wahrscheinlich sehr viel Material zusammengeschwemmt worden, das wird man auch als erstes untersuchen, aber man will sicherlich eben zu diesem Berg in der Mitte hinfahren, der aus verwittertem Material besteht. Das heißt also Gestein, das sehr, sehr lange im Wasser gelegen ist. Und dort hat man natürlich die Hoffnung, dass man eben nicht nur an der Oberfläche, sondern auch in den Spalten, in den Ritzen der Gesteine und der Gesteinsschichten nachschauen kann. Und Curiosity ist da dafür natürlich auch perfekt ausgerüstet, hat alles zum Bohren, zum Schleifen, zum Kratzen dabei.
Professor Ralf Jaumann, Dankeschön nach Berlin.
Ja, jetzt ist Moritz Wedel im Studio. Moritz, wir haben da eben die tollen Bilder gesehen, wie sich die Menschen, also die NASA-Mitarbeiter, gefreut haben. Irrsinnige Erleichterung. Das Ganze, dieses Landemanöver, war extrem kompliziert, oder?
Ja, auch der gesamte Flug war eine Mammutaufgabe für die Experten der NASA. 900 Kilogramm mussten transportiert werden von der Erde zum Mars. So viel wiegt dieses Mars Science Laboratory und davon ist ja dieser Rover, dieser Curiosity nur ein kleines Stückchen. Schauen wir uns das mal an. Also hier dieses Marschflugmodul, das hat dafür gesorgt, dass überhaupt der Rover erstmal zum Mars gekommen ist. Er hat die ganze Reise gesteuert. Dann sehen wir hier diese Kapsel und in dieser Kapsel, da steckt die Abstiegsstufe, die wiederum hat den Rover, den wir hier sehen, zu Boden gelassen, auf den Mars sicher landen lassen. Das wurde das allererste Mal so gemacht mit diesen Seilen. Bevor das aber passieren konnte, musste ein waghalsiges Bremsmanöver überstanden werden. 16 Meter groß war dieser Fallschirm, den wir hier sehen. Der hat sich geöffnet in 11 Kilometern Höhe und dann gab es eine Bremsung, die es in sich hatte, von 21.000 Kilometer pro Stunde auf 3 Kilometer pro Stunde und das innerhalb weniger Sekunden. Auch das hat er gut überstanden, der Curiosity, und deshalb freut er sich natürlich jetzt heil auf dem Mars zu sein, wie wir hier auf Twitter lesen können. I'm safely on the surface of Mars. Gut, da twittert er natürlich nicht selber, sondern NASA-Kollegen, aber sie versuchen, diesem wunderbaren Hightech-Roboter so ein bisschen ein menschliches Antlitz zu geben und die Menschen so zu interessieren. Und Bilder werden auch immer ins Netz geschickt, damit man ganz hautnah dabei sein kann, wenn Curiosity sich umschaut auf dem roten Planeten.
Besten Dank für diesen Überblick, Moritz.
Ja, irgendwann werden sicher auch mal Menschen, Astronauten zum Mars fliegen, aber noch ist das natürlich Zukunftsmusik.
Getestet wurde es schon mal hier auf der Erde. Ein Langzeitexperiment hat es gegeben. Die Bedingungen, ähnlich eben wie bei einer bemannten Mars-Mission, echt nachgestellt. Mars 500 hieß es, griffige Form, es waren sogar ein paar Tage mehr. Freiwillige waren in einer Raumkapsel in Moskau eingeschlossen.
Und im Prinzip wollte man so vor allem herausfinden, wie die Menschen mit der Einsamkeit auf so einer extrem langen Reise zurechtkommen.
4. November 2011, Punkt 11 Uhr in Moskau. Das Ende einer Mission, der ersten bemannten Mars-Mission, wenn auch nur in der Simulation, also praktisch im Reagenzglas. Mit 6 Testastronauten, 3 Russen, ein Italiener, ein Chinese und ein Franzose. Sie haben es geschafft, hin zum Mars und wieder zurück zur Erde. 520 Tage haben sie ausgehalten im nachgebauten Mars-Raumschiff. Wir sind stolz darauf, bewiesen zu haben, dass Menschen zum Mars fliegen können. Für mich als ESA-Mitglied war es eine Ehre, mit diesen 5 hochprofessionellen und freundlichen Menschen mit einer unglaublichen mentalen Widerstandskraft zusammenzuarbeiten. Dafür, dass wir morgen den roten Planeten sehen werden. Die Simulation sei viel schwieriger als ein wirklicher Flug, hatte der Italiener schon vorab in einem Interview verraten. Ein wirklicher Flug sei viel aufregender. Stattdessen habe er sich oft einsam gefühlt und Monotonie gespürt. Und dabei war Urbino noch einer der beiden Raumfahrer, die den Container kurz verlassen durften. Nach mehr als 8 Monaten auf dem Höhepunkt der Mission während der Landung auf dem Mars. Gut 50 Minuten dauerte der Ausflug auf den nachgestellten roten Planeten, stilgerecht im Raumanzug. Die ersten Mars-Besucher entnahmen nicht nur Bodenproben und suchten nach Leben, sie rammten auch Russlands und Europas Flagge in den Testsand. Die größte Herausforderung des Projekts war nicht die Technik, es waren die Menschen. Der Mond mit nicht mal 400.000 Kilometern Entfernung liegt quasi noch um die Ecke. Aber der Mars ist 150 Mal so weit weg, mehr als 55 Millionen Kilometer. Totale Isolation, kein Tageslicht, immer die gleichen Menschen. Der Test sollte vor allem das Gruppenverhalten simulieren unter Männern.
Vor ein paar Jahren, da war eine Frau dabei. Und nach einer gewissen Zeit, ein paar Monaten, fingen sich die Männer an zu prügeln, wegen der Frau, bei einer Neujahrsfeier. Das geht nicht.
Geprügelt haben sie sich bei dieser Mission wohl nicht, doch es ging bei dem simulierten Marsflug nicht nur um das Seelenleben der Probanden. Erstmals hatten die beobachtenden Forscher eine Gruppe für medizinische Tests unter totaler Kontrolle. Rund 15 Millionen Dollar haben Russen und Europäer für das Mars-Experiment veranschlagt. Der wirkliche Flug zum Mars wird viel teurer. Zwar dürften noch bis zu 50 Jahre vergehen, bis es wirklich losgeht, doch diese 6 Männer haben jetzt schon eine Ahnung davon, wie sich die lange Reise zum roten Planeten anfühlt.
Dr. Günter Reitz, Strahlenbiologe und Physiker beim Deutschen Zentrum für Luft- und Raumfahrt ist da. Schönen guten Tag. Eben haben wir schon ein bisschen gescherzt. Leider waren Sie noch nicht da oben auf dem Mars. Würden Sie denn wirklich hinreisen wollen?
Na, ich bin schon etwas älter, wäre interessant. Die Reise ist sehr lange, im Augenblick noch. Also man spricht immer über 1000-Tage-Szenarien oder auch 600 Tage. Aber ich hoffe, dass man das in Zukunft doch durch geeignete Antriebe doch etwas verkürzen kann.
Jetzt ist Curiosity also oben. Der Roboter fährt bald herum, aber es sollen irgendwann Menschen sein. Ist das realistisch?
Durchaus. Ich würde darauf arbeiten wir hin. Wir arbeiten, die Vision an für sich ist natürlich sowieso Besiedlung des Sonnensystems in ferner Zukunft durch den Menschen. Und das wäre der erste Schritt. Erstmal natürlich auch zum Mond, dann zum Mars. Doch, ja.
Sie haben den Mond angesprochen. Wir wissen relativ viel über den Mars, relativ wenig eigentlich über den Mond, wenn ich das so recht verstehe. Wieso ist der Mars so interessant?
Ja, der Mars ist natürlich insofern interessant, dass man da nach Vorstufen des Lebens halt schauen möchte und überhaupt, ob Leben da ist. Beim Mond ist es ein bisschen schwierig. Der Mond hat überhaupt keine Atmosphäre. Ja. Das heißt, die Mondoberfläche wird natürlich dauernd auch von dem sogenannten solaren Wind bombardiert, ja, sodass da die Chancen zumindest etwas geringer sind, obwohl ja auch Wasser zum Beispiel auch schon festgestellt worden ist. Aber gut.
Der rote Planet ist ja auch nicht so richtig einladend. Wie sind die Bedingungen da?
Nein, einladend ist er nicht. Aber vielleicht kann man ihn ja verbessern, sage ich mir. Aber gut, nein, wir haben natürlich da eine reduzierte Atmosphäre. Das heißt, wir haben eine CO2-Atmosphäre. Es ist ziemlich kalt und heiß, abwechselnd. Es ist nicht so schön wie hier auf der Erde. Der Druck ist geringer. Die Strahlenumgebung, und das ist unser Feld, ist etwas wie man so schön sagt, etwas harscher. Das heißt, wir haben eine sehr viel höhere Strahlenbelastung als hier auf der Erde. Ja. In dem Sinne ist er natürlich zunächst mal lebensfeindlich, aber man kann natürlich, dort landen, kann ihn begehen in Raumanzügen, kann natürlich auch Gebäude oder gebäudeähnliche Strukturen errichten und kann natürlich einen Vorposten da aufrichten.
Ein Ausblick in die Zukunft. Vielen Dank, Dr. Künder-Reitz, für dieses Wissen, das wir hoffentlich irgendwann auch noch erleben werden. Und jetzt macht Romy weiter.
Ja, nun ist die Sonde Curiosity heute Morgen also heil auf dem Mars gelandet. Und das ist nicht nur wissenschaftlich ein riesiger Erfolg für die NASA-Ingenieure. Es ist auch ein bisschen Balsam für die geschundenen amerikanischen Raumfahrerseelen. Schließlich musste die NASA erst im vergangenen Jahr ihr Space-Shuttle-Programm beenden, auch aus Geldmangel.
Das war ein Bilderbuchstart in Cape Canaveral am 8. Juli 2011. Zum letzten Mal fliegt ein Space Shuttle ins All. 12 Tage dauert die Mission zur ISS und wieder zurück und sie schließt ein langes Kapitel Raumfahrtgeschichte. 30 Jahre lang waren die Fähren die Lastesel der NASA, doch sie gerieten mit der Zeit mehr und mehr in die Kritik. Denn was als preisgünstiger Pendelverkehr ins All gedacht war, wurde am Ende extrem teuer. Und im Vergleich zur robusten Technik der russischen Transporter waren die Shuttles technisch kompliziert.
Das Space Shuttle ist überflüssig geworden. Vor allem die Kosten rechtfertigen den Nutzen nicht mehr. Nun werden wir Russen über Jahre viel günstiger Material und Menschen ins All bringen. Aber es wird die Zeit neuer, profitabler Transporter kommen.
Die Unterstützung der Öffentlichkeit verlor das Shuttle-Programm endgültig beim Absturz der Columbia 2003. Die gesamte Crew kam ums Leben, wie auch schon beim ersten Shuttle-Unglück 1986, als die Challenger kurz nach dem Start explodierte. Beide Male waren eklatante Sicherheitsmängel die Ursache. In der Region rund um Cape Canaveral lebten tausende Menschen jahrzehntelang vom Shuttle-Tourismus. Viele fürchten, ihren Job zu verlieren.
Hier war immer so viel los, dass wir fast nicht hinterherkamen. Das ist jetzt alles vorbei.
Wann die NASA wieder Menschen ins All schießen wird, steht in den Sternen. Das von George W. Bush einst verkündete, ehrgeizige Nachfolgeprogramm für die Shuttles, das bemannte Missionen bis zum Mars vorsah, wurde wieder gestrichen.
Die Rolle von Menschen im All steht generell auf dem Prüfstand. Das meiste können mittlerweile Roboter viel günstiger erledigen. Es bleibt die Frage, was können Menschen im Weltraum wirklich für die Wissenschaft leisten?
Eine Skepsis, die die übrige Welt nicht unbedingt teilt. So plant China für 2024 einen bemannten Flug zum Mond, die Europäische Raumfahrtagentur 2033 einen zum Mars. Und vor wenigen Tagen beeindruckten die Russen auch noch die Raumfahrerwelt. Ein unbemannter Raumtransporter dockte an der internationalen Raumstation ISS an. In nur 6 Stunden statt den bislang üblichen 2 Tagen. Für US-Präsident Obama aber hat Amerika die Vormachtstellung, nicht nur in der Welt, sondern auch im All. Mit der Marslandung jetzt sei das bewiesen. Das fahrende Hightech-Labor auf dem roten Planeten sei eine beispiellose Technologieleistung. Die USA hätten auf dem Mars Geschichte geschrieben. US-Präsident Obama, er will auch zur bemannten Raumfahrt zurück, sie aber weitgehend privatisieren. Mehrere US-Unternehmen entwickeln derzeit Raumfähren. Einsatzbereit sollen sie in 3-4 Jahren sein.
Das Ende von etwas bedeutet doch immer auch den Anfang von etwas Neuem. Es wird kein Ende der bemannten Raumfahrt geben.
Sie war 39 Mal im All, so oft wie kein anderer Space Shuttle. Ihren letzten Flug aber muss die Discovery nicht allein absolvieren. Auf dem Rücken einer umgebauten Boeing 747 dreht sie eine Ehrenrunde über Washington. Nach über 30 Jahren, voller Erfolge und Rückschläge, ist sie nun im Museum gelandet.
Nun hat die US-Raumfahrtbehörde NASA bestätigt, die unbemannte Marssonde Curiosity ist erfolgreich auf dem roten Planeten gelandet. Das 900 Kilogramm schwere Roboterfahrzeug sendet bereits erste Signale und Fotos vom Mars. In den kommenden 2 Jahren soll Curiosity dort nach Spuren von Leben suchen. Mehr dazu von Angela Friedrich.
Minutenlang jubelten die Mitarbeiter im Kontrollzentrum in Pasadena im US-Bundesstaat Kalifornien. Verständlich, denn bei der Roverlandung hätte auch viel schiefgehen können. Kurz nachdem Curiosity festen Boden unter den Rädern hatte, sendete er die ersten Bilder vom roten Planeten. Bevor es losging, bin ich rausgegangen, habe nach Westen geschaut und den Mars gesehen. Ich habe gesagt, bald wirst du einen Besucher haben. Und der Planet hat gelächelt. Ich wusste also, dass es klappen wird. Wie geplant ist Curiosity um 7:31 Uhr mitteleuropäischer Zeit im Gale-Krater gelandet. 7 Minuten brauchte die Sonde für die Landephase, um von knapp 21.000 Kilometern pro Stunde auf 0 abzubremsen. Auch in Deutschland bei der Europäischen Raumfahrtorganisation ESA gab es erleichterte Gesichter nach der Landung. Für die nächsten 2 Jahre wird das 6-rädrige unbemannte Fahrzeug den Mars nach Hinweisen auf Leben untersuchen. Dafür hat Curiosity eine ganze Reihe von Messinstrumenten an Bord, auch ein Strahlenmessgerät von der der ESA.
Die ganz zentrale Frage ist, gibt es Leben auf dem Mars? Man kann sich da jetzt natürlich nicht vorstellen, dass man da irgendwelche kleinen grünen Männchen findet. Das mögen Viren, Bakterien, Einzeller sein.
Insgesamt $2 Milliarden lässt sich die NASA die teure Mission kosten. Denn nachdem im vergangenen Jahr das Shuttle-Programm der US-Raumfahrtbehörde eingestellt wurde, ist Curiosity das neue Vorzeigeprojekt.
Geht's an die Arbeit. Seit knapp 6 Stunden hat die Menschheit einen neuen Kundschafter auf dem Mars. Der irdische Neuankömmling hört auf den Namen Curiosity, zu Deutsch Neugier. Und diesem Namen soll er jetzt alle Ehre machen, denn der Roboter auf Rädern, hier sehen wir ihn im Maßstab 1:1, soll vor allem die chemische Beschaffenheit des roten Planeten analysieren. Die Erkundungsfahrten sollen die Menschheit der Erfüllung eines alten Traumes näher bringen, eines Tages einen Menschen auf den Mars zu schicken. Die Landung des Roboters feiert heute allerdings nicht nur die amerikanische NASA. Auch im Raumflugkontrollzentrum der Europäischen Raumfahrtbehörde, der ESA in Darmstadt, wird gefeiert. Denn die Wissenschaftler und Techniker dort haben großen Anteil am Erfolg dieser Mars-Mission.
Ohne sie wäre alles noch viel unsicherer gewesen, denn sie hatten mit der ESA-Sonde Mars Express den besten Blick auf die kritischste Phase der neuen Mars-Mission, die letzten Minuten vor der Landung.
Wir haben natürlich mit unseren Kollegen von der NASA mitgefiebert. Man weiß, es kann viel, viel schief gehen, obwohl das so oft simuliert wurde. Wir sind natürlich heilfroh, dass die Landung hervorragend geklappt hat.
570 Millionen Kilometer hatte Curiosity seit dem Start im vergangenen November bereits zurückgelegt. Doch wirklich kritisch wurde es erst auf den letzten paar tausend Metern. Innerhalb von nur 7 Minuten musste die Kapsel mit dem Rover von 21.000 Kilometern pro Stunde gezielt heruntergebremst werden. Zunächst mit einem Überschallfallschirm, dann mit einer Technik, die die NASA erstmals ausprobierte. Ein fliegender Kran setzte den Rover auf der Oberfläche ab. Jeder Fehler hätte alles zunichte gemacht. Ein ehrgeiziges Manöver mit einem ebenso ehrgeizigen Ziel.
Es sind eine Vielzahl neuer Instrumente an Bord, die es ermöglichen, also neue Untersuchungen, was die Atmosphäre die Zusammensetzung der Atmosphäre angeht, die Zusammensetzung des Bodens, die Suche nach Wassereis oder in gebundener Form in dem Gestein, in dem Regolith durchzuführen und natürlich insbesondere die möglicherweise den Nachweis für Leben zu erbringen. Das wäre natürlich eine absolute Sensation, wenn das gelingen würde.
Die Hoffnung, dass der Nachweis dieses Mal gelingt, ist groß, denn der Landeplatz für Curiosity wurde genau auf das Missionsziel abgestimmt. Der Gale-Krater liegt in einem Gebiet mit leicht zugänglichen Erdschichten aus etlichen Jahrtausenden Marsgeschichte. Hier wollen die Forscher fündig werden.
Man sucht nach Ton, also so eine Art von Erde, die entsteht nur, wenn es für längere Zeit Wasser gibt. Und das könnte so Ideen geben über die Entstehung von Leben vielleicht auf dem Mars oder auch nicht. Das ist natürlich immer die große Frage.
Die ersten Bilder des Rovers zeigen, die Mission ist erfolgreich angelaufen. 23 Monate lang soll Curiosity die Marsoberfläche nun untersuchen. Bis zu 200 Meter legt er dabei pro Tag zurück. Kleine Schritte für einen Roboter, aber hoffentlich ein großer Sprung für die Weltraumforschung.
And he mentioned how big Curiosity is compared to past versions. Now, let's bring up a side-by-side look at the last 3 generations. Sojourner is the small one right in the middle, that little itty-bitty thing. It landed on Mars 15 years ago, and that makes it one of a few successes. NASA made this scorecard ahead of Curiosity's landing, and it shows the results of 39 missions targeting Mars. As you can see, 15 made it, but most failed. Now let's update that scorecard with another win for Earth. And as for the U.S. alone, it now has 14 successes out of 19 attempts. And that is Newsstream. But the news continues at CNN. World Business Today is next.
Scenes of celebration at the American Space Agency when its robotic vehicle Curiosity successfully landed on Mars, having completed a 570 million kilometer journey from Earth lasting nearly 9 months. Scientists call the descent onto Mars the 7 minutes of terror because the probe went through a blind spot from Earth. We hope for news of what that probe has managed to photograph in due course.
Präsident Obama sagte, die USA hätten auf dem Mars Geschichte geschrieben.
Minutenlanger Jubel im NASA-Kontrollzentrum in Kalifornien. Die Landung ist geglückt. Der Mars-Rover mit dem Namen Curiosity hat sicher auf unserem Nachbarplaneten aufgesetzt und ist voll funktionstüchtig. Das Team kann es kaum fassen. Jetzt, wo wir das geschafft haben, sind wir so gespannt auf die Entdeckungen, die die Mission machen wird. Und wir freuen uns schon darauf, noch mehr Einsätze auf dem Mars zu machen und auf anderen Planeten. Das ist wirklich eine mächtige Sache, die wir hier machen. Die Landung ist ganz nach Plan gelaufen. In genau 7 Minuten wurde Curiosity, wie in dieser Animation vorausgeplant, von fast 21.000 Stundenkilometern auf 0 heruntergebremst. Der Fallschirm öffnete sich und das Hitzeschild fiel ab. Pünktlich um 7:31 Uhr unserer Zeit berührte der Roboter die Oberfläche des Mars. Für dieses Meisterstück gab es auch Lob und Gratulation aus Deutschland.
Und dass man den Landeort innerhalb weniger Meter getroffen hat und auch fast zu der vorhergesehenen Zeit mit ein paar Sekunden Abweichung, dann ist das eigentlich unglaublich.
1,9 Milliarden Euro hat diese Mission gekostet. Dafür ist jetzt der modernste und technisch am besten ausgestattete Mars-Rover auf dem Mars. Das Spektakel wurde auch in Deutschland live beobachtet. An der Universität in Kiel sind etwa 500 Besucher beim Public Viewing gewesen. Jetzt dürfen sich die NASA-Forscher auf viel Material freuen.
Scientists and engineers celebrate the historic landing of Curiosity. The Mars rover cost $2.5 billion and traveled across hundreds of millions of kilometers to get to the red planet. Well, now comes the fun part, searching for signs that there ever was or might still be life on Mars. CNN's John Zarella has been closely covering the mission, of course, joins me now from Pasadena, California's Jet Propulsion Laboratory. You know, John, I was saying the word boffin. I don't know if it's used much in the United States, but you know, I've never seen so many boffins quite so excited.
You know, and boy, I tell you what, it was really a good thing to see because there was a tremendous amount of pressure on the NASA folks, the NASA team, for this to go right. This was the last of the big picture missions to Mars that's on the table. A couple of smaller missions, one with the Europeans and another one that they're talking about, but nothing this grandiose. The last of the grand exploration missions. And the hope was that if they could pull this off, never before attempted landing the way they did it, the way they had to carry it out, if they could pull it off, that it might jumpstart the whole idea of continuing Mars exploration. And the reason, Michael, they had to do it the way they did it, flying through the atmosphere 13,000 miles an hour, a parachute deploying, then a series of pyrotechnic events, then a sky crane dropping the vehicle down to the planet, was because if you look behind me, that's a mock-up of the Curiosity rover. It's 2,000 pounds. It's the size of a small car, and there was no other way that they could figure out to get something that big in one piece on the surface, and they did it. And as I was talking to one of the members of the engineering team, he said to me, "You know what? I don't have to have nightmares anymore about this. It's over. They did it, and Curiosity's on the ground."
And before you go, I got to say, okay, what now?
Yeah, well, what now? That's it. So now for the next couple of weeks, we're going to be getting images back. We're going to get some new pictures this afternoon. We will get a picture in just a couple of hours that shows Curiosity coming through the atmosphere. It's parachute deployed. That picture taken from the reconnaissance orbiter overhead of Mars. Later today, you know, remember those great images from Apollo where you could actually see the dust coming up as the Apollo spacecraft were landing? Well, they had a descent camera on this vehicle. We're going to get some of those images later today. And then the science will begin, and they will be out looking for the building blocks of life. Carbon, water, methane gas. They can't detect life itself, but with this rover, they can get us one step closer to answering that question. Did life ever exist on Mars? And perhaps does it still?
Yeah, Michael? I know you love this stuff too, John, as do I. It's amazing, isn't it? And I love the graphics. All right, good to see you, my friend. We'll check in with you a little later. John Zarella there. Master, if you're going to go live there, if we're going to colonize, you'll need to take a jacket.
That's right. Curiosities about Mars here that I want to show you. Let's go ahead and, oh, there I am. Look at that magic. Let me go ahead and show you what we have. This is Google Mars. Did you know they have that? Kind of like Google Earth, but we have Google Mars too, and Google Moon and Google Space. Let's go ahead and talk about Google Mars here and talk about the red planet. This is the Gale crater, very close to where Curiosity actually landed, and they didn't pick the site at random. There's a reason why NASA is aiming for Mars. It's because of the way it looks. Why didn't they go to Venus, right? Well, it's farther away, but Mars has a solid surface. They know that, and they can see it a little bit easier. This is the Gale crater, as I was telling you, and it's an area of geological interest. You see all these dots and all of these different things. Those are other impacts and other interesting features in the topography of Mars that make it extremely interesting for scientists to actually go there. They think that some of these ripples and some of these things, these scars that we see on the red planet may have actually been formed by water. There's other really cool things like this right over here. This is Olympus Mons, and it's actually a volcano. It's the tallest volcano in our solar system, and at about 27 kilometers, it's hard to tell here because it's just so wide. At about 27 kilometers, it's actually 3 times taller than Mount Everest. I thought that was pretty cool. And check this out, Michael. This right here, this is called Valles Marineris, and it's 100 kilometers wide on average and 10 kilometers deep. Imagine something 10 times deeper than the Grand Canyon, and they say this may have been caused by water as well. And then after that, even though it's longer than the Mississippi River, that's not all. There's more. There's vast plains like this one right over here, and they say maybe this was created by water. You know, when you go to the beach and the water leaves and the sand is nice and smooth, well, they say this may be one of those places.
Yeah, I don't know why we need to be sending these missions to Mars. Just use Google Mars and, you know, we'll see if anybody's standing out the front of their house. Hey. Be able to find out that way. All right, good to see you, Mari Ramos there.
UFO-Alarm auf dem Mars. Die Marsianer, falls es welche gibt, bekamen heute spektakulären Besuch von der Erde. Aus dem All schwebte Curiosity, die Neugier, am Überschallbremsschirm auf den roten Planeten und setzte butterweich auf. Zum Glück, sonst hätte die NASA Milliarden in den Marssand gesetzt. Stattdessen gab es schon erste Marsbilder und zur Feier des Tages Schokoriegel für die NASA-Truppe. Die Marke ist ja wohl klar. Peter Hantjes.
Sie freuen sich wie kleine Jungs über ein heiß ersehntes Weihnachtsgeschenk. Die erfolgreiche Landung lässt eine Riesenlast von den Schultern der Wissenschaftler fallen. Und als kurz darauf auch noch das erste Foto des Mars-Roboters auf der Leinwand erscheint, sind einige kaum noch zu halten. Der Landeplatz scheint unglaublich sauber zu sein. Wir hatten auf eine gute Landung gehofft, doch das hat unsere Erwartungen übertroffen. Zum Glück, denn Curiosity hatte angezogen von der Gravitation des Mars zuletzt auf mehr als 20.000 Stundenkilometer beschleunigt, bevor ihn ein Überschallfallschirm in gerade mal 7 Minuten für die Landung abbremsen musste. Eine Art raketenbetriebener Kran seilte den Rover schließlich auf die Marsoberfläche ab. Dort soll das Familienvan-große Vehikel seinem Namen Curiosity, zu Deutsch Neugier, alle Ehre machen und nach Leben suchen.
Die zentrale Frage wird sein, kann man den Nachweis für Leben erbringen, Einzeller, irgendwelche Amöben, was auch immer, vielleicht auch nur ein Anzeichen dafür, dass es früher mal existiert hat, aber das wäre wirklich die absolute Sensation.
Doch erst einmal freuen sich die deutschen Raumfahrtexperten mit ihren amerikanischen Kollegen über die erfolgreiche Landung. Schon bald könnte es in Darmstadt ähnliche Szenen geben, wenn ESA-eigene Rover auf dem Mars landen. Kaum noch zu halten. Der Landeplatz scheint unglaublich sauber zu sein. Wir hatten auf eine gute Landung gehofft, doch das hat unsere Erwartungen übertroffen. Zum Glück, denn Curiosity hatte angezogen von der Gravitation des Mars zuletzt auf mehr als 20.000 Stundenkilometer beschleunigt, bevor ihn ein Überschallfallschirm in gerade mal 7 Minuten für die Landung abbremsen musste. Eine Art raketenbetriebener Kran seilte den Rover schließlich auf die Marsoberfläche ab.
Der kleine Roboter auf 6 Rädern soll nach Leben auf dem roten Planeten suchen. Die Mission gilt zudem als Testlauf, um Menschen zum Mars zu bringen. Jan Bulich berichtet.
Die Nervosität im kalifornischen Kontrollzentrum ist mit Händen greifbar, bis die Meldung der geglückten Landung kommt. Und dann funkt Curiosity seine ersten Bilder vom Mars. In diesem Augenblick bahnt Curiosity den Weg für menschliche Fußstapfen auf dem Mars. Das fortschrittlichste Roboterfahrzeug aller Zeiten ist jetzt auf dem roten Planeten. 8 Monate brauchte die Sonde für die 250 Millionen Kilometer Entfernung zwischen Mars und Erde. Heute Morgen bremste sie von 21.000 auf 3 Stundenkilometer ab, um dann, wie die Simulation zeigt, den Roboter abzuseilen. Die Europäische Raumfahrtbehörde unterstützte die 2,5 Milliarden Dollar teure amerikanische Mission mit Satellitendaten. Deutsche Forscher halfen bei der Entwicklung. Bereits 1975 landete die erste Sonde erfolgreich auf dem Mars. Doch keine der bisherigen Missionen fand, was in den kommenden 2 Jahren nun Curiosity suchen soll.
Das Hauptziel ist es wirklich, den Nachweis zu erbringen, ob es auf dem Mars Leben gibt oder vielleicht mal Leben gegeben hat in Form von Einzellern, von Amöben, von Sporen, was auch immer.
Es geht aber auch ums Prestige. US-Präsident Obamas Devise, in 2 Jahrzehnten auch Menschen auf den Mars zu schicken, rückt näher. Auch Russland und die Europäische Raumfahrtbehörde üben bereits die bemannte Mission zum roten Planeten.
Heute aber haben wir den Mars geentert mit der NASA-Sonde Curiosity.
Ja, es ist das größte Forschungsfahrzeug, das den Mars je erreicht hat. So groß wie ein kleines Auto, kann man sagen. Und deshalb begeisterte diese Landung heute wirklich weltweit.
Ja, und auch deutsche Technik steckt drin und soll jetzt nach Leben auf dem Mars suchen. Rund 2 Milliarden Euro kostet das Ganze. Und deshalb war das eine spannende Landung heute.
Und schon wenige Minuten nach dieser Landung funkte Curiosity die ersten Bilder von der Marsoberfläche. Mission geglückt. Mit 21.000 Stundenkilometer raste die Sonde heute Morgen in die Atmosphäre des Mars. Temperaturen von 1600 Grad musste sie dabei überstehen, um dann abrupt mit Fallschirmen abgebremst zu werden. Das Marsmobil hat tatsächlich die Ausmaße eines Kleinwagens und musste von einem mitfliegenden Kran abgeseilt werden. Ob all diese waghalsigen Manöver geklappt hatten, erfuhren die NASA-Mitarbeiter erst, als das Funksignal der Sonde bei ihnen ankam. Die Wissenschaftler nannten diese Zeit die 7 Minuten des Grauens. Mit an Bord Messinstrumente aus Köln. Günter Reitz vom Deutschen Luft- und Raumfahrtzentrum hat sie mitentwickelt. Auch er verfolgte heute gebannt die Landung.
Das heißt, jetzt ist das Vielleicht haben Sie die kleine Träne gesehen. Also ich habe mich wirklich gefreut. Es war auch sehr erregend und ich springe natürlich nicht auf, aber ich bin natürlich sehr glücklich, dass wir jetzt auf dem Mars sind und schaue dann mit Erwartung oder erwartungsvoll in die Zukunft, dass wir auch unser Instrument initialisiert kriegen und dass wir dann die ersten Daten von Mars bekommen.
Ralf Jaumann ist Direktor des Instituts für Planetenforschung im DLR. Er erhofft sich ganz neue Erkenntnisse durch das 900-Kilo-Gefährt, vor allem ob es auf dem Mars früher einmal Leben gegeben hat.
Curiosity kann alles, es kann bohren, kratzen, es kann in Spalten rumfischen, es kann all das holen, was der Wissenschaftler sich begehrt und kann es dann auch noch chemisch untersuchen, bis runter zu eigentlich den atomaren Verbindungen, die da vorkommen.
Die Detektoren des DLR sollen die kosmische Strahlung messen. Voraussetzung für die erste bemannte Mars-Mission.
Es ist natürlich der große Traum der Menschheit, zum Mars zu kommen oder auch im gesamten Sonnensystem eben Untersuchungen durchzuführen, sich auch zu verbreiten. Ich finde, das solare System ist ein geeigneter Lebensraum und der sollte genutzt werden. Das ist unsere Vision.
200 Meter rollt die Sonde nun täglich über den Mars. 2 Jahre lang soll erforscht werden, ob es auf unserem Nachbarplaneten jemals Leben gegeben hat und ob dort in Zukunft Menschen leben können.
Es ist eine Sternstunde für die Raumfahrt. Mehr als 8 Monate war er unterwegs. Jetzt ist der Roboter Curiosity, auf Deutsch Neugier, auf dem Mars angekommen. Curiosity ist, wie Sie hier sehen, so groß wie ein Kleinwagen und damit das bisher größte Fahrzeug auf dem roten Planeten. Er soll die Frage klären, ob es hier einmal Leben gab. Mit einem Laser untersucht der Roboter die Marsoberfläche. Für genauere Analysen sammelt er Gesteinsproben ein. Die werden in einem eingebauten Minilabor stark erhitzt. In den freigesetzten Gasen hofft man dann, Spuren von Leben zu finden. Die erfolgreiche Landung wurde im NASA-Kontrollzentrum überschwänglich gefeiert. Shakuntala Banerjee berichtet.
Es ist die Erleichterung nach etlichen Jahren Arbeit, die sich hier Bahn bricht. Seit 2004 hat die NASA am neuen Mars-Rover getüftelt und die Idee zu der Mission ist noch älter. Um 7:31 Uhr europäischer Zeit der erlösende Moment. Das erste Funksignal des gelandeten Rovers erreicht die Erde. Das war eine verrückte Nacht, auf die haben wir mehr als 12 Jahre gewartet. Jetzt passiert es, jetzt geht's endlich los. Das Landemanöver war das ehrgeizigste in der Geschichte der NASA. 7 Minuten Präzisionsarbeit inklusive einer völlig neuen Landetechnik. Ein fliegender Kran setzt das Roboterfahrzeug in der Zielzone ab. Der deutsche Beitrag zum 2 Milliarden Euro teuren Mars-Abenteuer, die Überwachung der Landung durch ein Team der ESA. Hier sieht mancher den Rover als Wegbereiter für eine noch größere Mission.
Ich bin fest davon überzeugt, dass vielleicht in 2 Jahrzehnten, vielleicht in 3 Jahrzehnten dann auch irgendwann einmal Menschen auf den Mars fliegen werden, und auch das wird eine internationale Mission werden.
Curiosity wird fast 2 Jahre lang Daten und Bilder liefern. Alles für die Beantwortung einer Frage. Gab oder gibt es Wasser und damit vielleicht auch Leben auf dem Mars? An dem Projekt sind auch deutsche Wissenschaftler der Uni Kiel beteiligt. Ihre Arbeit hilft, die Strahlung auf dem Planeten zu erforschen. Auch wenn die ersten Bilder noch recht trübe wirken, die Aussichten auf Neues vom Mars sind seit heute ausgezeichnet.
NASA's Curiosity rover is wheels down on Mars and beaming back images of the red planet. Its 2-year mission is to seek out signs of life, past or present. It's starting with the Gale crater, which scientists believe may once have contained a lake.
Curiosity, auf Deutsch Neugier, ist auf dem roten Planeten angekommen und hat schon Bilder zur Erde gefunkt. Die Landung war weltweit mit großer Spannung erwartet worden. Denn in einem komplizierten Manöver musste Curiosity binnen weniger Minuten von rasender Geschwindigkeit auf 0 abgebremst werden.
Zittern bis zur letzten Sekunde. Dann endlich die erlösende Meldung: Touchdown für Curiosity. Die Marssonde ist sicher auf dem roten Planeten gelandet. Und die sonst so beherrschten NASA-Wissenschaftler lassen ihren Gefühlen freien Lauf. Nach knapp 570 Millionen Kilometern Wegstrecke eine Punktlandung. Planmäßig erreicht der ferngesteuerte Forschungsroboter sein Einsatzgebiet, einen Meteoritenkrater auf dem Mars. Curiosity, die ausgefeilteste Sonde, die je gebaut wurde, ist nun auf dem roten Planeten, um uralte Fragen zu beantworten, etwa ob es jemals Leben gab auf dem Mars oder ob dort in Zukunft Leben möglich wäre. Ab jetzt bahnt Curiosity da oben den Weg für uns Menschen. Schon wenige Minuten nach der Landung schickt Curiosity erste Schwarz-Weiß-Fotos von der Marsoberfläche zur Erde. Auch diese Bilder sorgen für Jubel beim NASA-Bodenpersonal. Es sieht so aus, als habe der 2,5 Milliarden US-Dollar teure Roboter die Landung unbeschadet überstanden. In den kommenden Jahren soll das Labor auf Rädern sich vor allem auf die Suche nach Wasser auf dem Mars machen. Am Times Square verfolgen viele New Yorker den nächtlichen magischen Moment. Die erfolgreiche Landung der Marssonde beflügelt die stolze Weltraumnation. US-Präsident Obama gratuliert und dankt der NASA per Twitter. Amerika habe erneut Geschichte geschrieben.
Weitere Bilder, Animationen und Informationen der NASA zur Mars-Mission finden Sie auf tagesschau.de.
Touchdown confirmed. We're safe on Mars. Following a daring plunge through the Martian atmosphere billed as 7 minutes of terror, the Mars Science Laboratory's Curiosity rover made a successful on-target landing on the red planet in Gale Crater. Confirmation of the newest resident rover's safe touchdown reached the MSL flight team courtesy of the Mars Odyssey spacecraft, which, from its vantage point orbiting Mars, was able to directly communicate with Curiosity. In addition to NASA TV and NASA.gov, coverage of Curiosity's landing was available for public viewing at various locations, including Times Square in New York City.
It's a huge day for the nation. It's a huge day for all of our partners that have something on Curiosity. And it's a huge day for the American people. So as I told people as we went around earlier tonight, everybody in the morning should be sticking their chest out saying, that's my rover on Mars, because it belongs to all of us.
For us, being able to land something in larger and larger measures with this capability will come the ability to land humans.
Many new technologies had to work in perfect succession and perfect synchronization for this to happen. It was an incredible performance by the Jet Propulsion Lab, by NASA, by the teams around the country who had contributed to this, and indeed partners from around the world.
Curiosity is scheduled to conduct a 2-year mission to investigate the most intriguing places on Mars in an effort to determine if microbial life is possible on the planet. We'll have more on Curiosity's landing with public reaction from NASA centers on the next edition of This Week at NASA. Engineers at the Johnson Space Center have conducted a successful 70-second test firing of the Project Morpheus lander. Morpheus is a vertical testbed vehicle demonstrating new green propellant propulsion systems and ALHAT, autonomous landing and hazard avoidance technology. This final test at JSC had the vehicle tethered to a crane and included a 60-second hover test with a 4-second ascent and a 6-second descent. The lander was later shipped to the Kennedy Space Center, where it's to undergo its first free flight testing.
17 meters, 03.
An unpiloted Russian resupply ship loaded with almost 3 tons of food, fuel, and supplies linked up to the International Space Station just 6 hours after its launch from the Baikonur Cosmodrome in Kazakhstan. Additional engine firings early in its mission were a test to expedite the Progress's journey to the orbiting laboratory, which normally takes about 2 days. After analysis by Russian engineers and managers, the technique could be used to similarly shorten a Soyuz vehicle's route to the station, thereby improving crew comfort as well as extending the life of the return vehicle while docked to the ISS.
You are our Olympians. You are the best of the best. You are the ones who help us reach for new heights.
Deputy Administrator Lori Garver led the 2012 NASA Honor Awards, recognizing those in the agency whose outstanding efforts in the past year have helped NASA reach new milestones. A new video spotlighting NASA's Curiosity rover was featured during a performance of the National Symphony Orchestra at Wolf Trap National Park for the Performing Arts outside Washington, D.C. The video from director Duncan Kopp was accompanied by a musical selection from late French composer Georges Bizet. The NSO was under the direction of conductor Émile Decaux. NASA Administrator Charlie Bolden was on hand for the performance.
This mission will not only help unlock the mysteries of Mars, it's a precursor to achieving President Obama's goal of sending humans to the red planet by the 2030s.
The Curiosity visuals were a portion of the NASA imagery featured as part of Gustav Holst's The Planets, the evening's main program. The 2012 NASA headquarters Take Your Children to Work Day gave younger NASA family members a peek inside the agency and its diversity of people and professions. Hands-on activities also represented tasks performed in some of the varied and exciting careers at NASA.
Those are American successes.
This summer has also been a learning experience at headquarters for a group of high school students. Administrator Charlie Bolden spoke to participants of the 2012 NASA Engineering Apprenticeship Program. NEAP targets high school sophomores, juniors, and seniors interested in science, technology, engineering, and math, the STEM careers. Under the 8-week program, students work on a project under the guidance of a volunteer mentor. NASA has hosted more than 200 students since the program began in 1995. Many NEAP students have gone on to top colleges and positions within NASA and other industry organizations.
Discovery, Endeavour, and Atlantis came home from space for the last time in 2011, touching down at the shuttle landing facility at Kennedy Space Center in Florida.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
After each final landing, Kennedy's landing operations team used a temporary spray paint to note where the wheels stopped. Local artist Chad Stout of C Spray Glass Blasting designed, manufactured, and installed the markers. Wearing safety gear, he etched the final design in absolute black granite, an extremely durable stone. Pavers are extra thick and weigh at least 100 pounds each, but he installed them by hand. All 3 pavers are aligned with the etchings on the runway centerline, and like the shuttle's legacy, will stand the test of time.
NASA has donated a piece of space shuttle history to the Coca-Cola Space Science Center at Columbus State University in Georgia. The Science Center has taken possession of main engine nozzle number 5002 from the Marshall Space Flight Center's Propulsion Research Development Lab. This particular nozzle has flown to space numerous times on 4 different shuttles, including the STS-60 mission in February 1994.
We have a go for engine start.
Commanding Space Shuttle Discovery for that flight, then astronaut Charlie Bolden, who is now, of course, NASA administrator. The NASA artifact will be displayed at the Coca-Cola Science Center to inspire the next generation of scientists and engineers. 15 years ago, on August 7, 1997, Space Shuttle Discovery launched from Kennedy Space Center on STS-85. Her crew, Commander Curtis Brown, pilot Kent Rominger, mission specialists Jan Davis, Bob Kerbeam, and Steve Robinson, and payload specialist Bjarne Tryggvason of the Canadian Space Agency worked for the complement of payloads focused on mission to planet Earth objectives, as well as the then upcoming assembly of the International Space Station. Among them, the Japanese Manipulator Flight Development, MFD, to evaluate the robotic small fine arm that later became part of the Japanese Kibo laboratory on the ISS. Discovery and crew returned to Earth 11 days later, landing safely at KSC on August 19th.
3, 2, 1, 0, and liftoff of Space Shuttle Endeavour.
5 years ago, on August 8, 2007, Space Shuttle Endeavour launched from KSC on STS-118, the 22nd shuttle flight to the International Space Station. Commander Scott Kelly, pilot Charlie Hobaugh, and mission specialist Rick Mastracchio, Dave Williams of the Canadian Space Agency, Barbara Morgan, Tracy Caldwell, and Al Drew continued construction of the ISS by delivering S5, the station's 3rd starboard truss segment. The crew also replaced a defective gyroscope and installed an external stowage platform. They closed out the mission 12 days later when Endeavour touched down on the runway at KSC.
And liftoff of the Atlas V with Juno on a trek to Jupiter.
And August 5th marks the 1-year anniversary of the launch of the Juno spacecraft atop an Atlas V rocket from Cape Canaveral Air Force Station in Florida. The launch marked the start of Juno's 5-year journey to Jupiter to study the planet's structure and decipher its history. And that's This Week at NASA. For more on these and other stories, or to follow us on Facebook, Twitter, and other social media, log on to www.nasa.gov.